Good morning, everyone, and welcome back to the second day of ArcheoFOSS conference. Today we are talking again about open tools, methods, data sets for our archaeology, and we are opening with, we're starting with a great paper we have Gabriele Gattiglia talking about the Arcade archive. The paper was submitted by Gabriele and Francesca Nichini. They are researchers of the archaeology. They are researchers in archaeology. Sorry, it's very early here where I am at the Mappa Lab of the University of Pisa. And Francesca is also working at the University of Pisa, and the floor is up to you, Gabriele.
Okay, thank you, Valeria. Thank you, everybody, for inviting us to talk about Arcade. So I can share my presentation. Okay, thank you very much. I speak also on behalf of Francesca Nichini, that now is on the mountains making survey. First of all, a short presentation of the Mappa Lab, which is the lab where we work. Is a lab related to digital archaeology, and especially it works with spatial modeling, predictive modeling, and mathematical application in archaeology. So in the last year, the lab explored also issues related to big data approach in archaeology, and also approaches related to artificial intelligence in archaeology, such as the presentation we are speaking about today, the Arcade project. The Arcade project was an H2020 project that started in 2016 and at the end of May 2019. The consortium was composed by 9 different institutions across the Europe, and also by companies, 2 archaeological companies and 1 ICT company. The coordinator was the University of Pisa with Mappa Lab, but the Italian department of CNR, Istituto di Scienze e Tecnologia dell'Informazione, also work in this project, together with the University of York, the University of Cologne, the University of Barcelona, and the University of Tel Aviv that developed the neural network. 2 archaeological company, Baraka and Elements from Spain, and 1 ICT company from Italy, Inera. So the idea of our project was to recognize automatically pot share when found in an excavation or in a field work. Till today, this step is made manually. It's a very time-consuming activity that need the expertise of many specialists and the use of huge paper catalogs. So, as you can see in this short video, the idea is very simple. When you find a potshare in your excavation and you don't know which kind of potshare is, you can ask Arcade. You can ask it only through one image, just taking a picture of your potshare and sending this picture to our neural classificator that was developed through artificial intelligence. In this way, you have 5 different answers that can match with your potshare. You can choose the right one going through the catalog, and you can share also your information with all the world if you want. In this way, you can share the finding of one single pod share, or we can see later, you can share the pod share of all your site. How this process was possible? Through three main steps. The first one is the creation of a digital comparative collection. That means a big database with all the information that were needed for the recognition. For doing this, together with the CNR IST in Pisa, it was developed an automatic workflow for paper digitization. This was made automatically when the catalog was very well structured, and it was made semi-automatic for all the catalogs that are not so well structured. The final step was the development of two different learning algorithms, two different neural networks. One for image, that means the decoration of the pottery, for recognizing the decoration of the pottery, and the second one for the shape of the pottery. So in this moment, we have two different classificators that are able to classify, to recognize images, decoration, or the shape, the type of a pot share. But this is not the core of my presentation, because we explained arcade in many other sessions and presentations. Now we want to focus on a very interesting aspect, the aspect of digitization of this paper catalog, and especially the aspect related to IPR, to the copyright that covered many of these catalogs. So for adding data, for populating our database, we used many different paper catalogs, and many of them were covered by copyrights. In some cases, we used open data material, as in the case of Roman amphora, that we use the ADS digital records related to Roman amphora. But in many cases, we used copyright material. And this was the first problem. It was possible to use all this material. So we start studying the European legislation, especially two directives. The first one that is related to the copyright, and the second one that is related to the database protection. This was needed because, first of all, we have to understand the general European legislation, because in many cases, the national legislation are very different, only partially affected the European legislation. Just for making an example, it was impossible to scan books for research purposes in Spain until 2016, because they haven't an exception for scientific research. And we decided to scan the paper catalogs in Italy because we have a more open legislation in this case. Anyway, we use the scientific exception related to these two directives. As regards of the area of copyright, all the published works mentioning of the source and the author's name can be used to the extent justified by a non-commercial purpose. The use of the structure of published database can only be used or mentioning the source always to the extent by a non-commercial purpose. And this fits well with our purpose, that is a research purpose. Just the same for the sui generis right, and also in this case, we can use databases to the extent justified by non-commercial purpose. So for the scientific exception, we could use all the data for scientific purposes. But one important aspect that we haven't only used the data coming from the paper catalogs, but we have enriched this data, adding new information. For example, we extract automatically from the drawings, from the 2D drawings, 3D models. And also we make analysis. We added data about distribution of pottery, new site location where pottery was found. So we enriched the original data set that was in the paper catalog. For this reason, we started a proof of concept with some publisher. Our idea was that if we haven't the possibility to use all the material when we expose our database to the public, because the material was covered by copyright, we can reach an agreement with publisher, an agreement that can allow the in-app purchase of some of the content. For example, we explored the possibility of selling the data into the catalogs, except for the data created by ourselves or the data coming from open data repositories. We can sell one type, for example, or one whole catalog, or, that is the best of the possibility from my point of view, we can sell material related to the catalogs. For example, we can have for free the data into the catalogs, and we can offer the in-app purchase of other material, for example, papers related to the argument, other paper related to terra sigillata or to some type of amphora. Anyway, we applied for the open data policy in H2020. So at the end of the project, we created an open data archive on the Archaeology Data Service of the University of New York with all the data produced by ourselves. So in this moment, we have open access data related to data included into the paper catalogs, but we have also open data for all the data created by ourselves during the project. In the Arcade portal, into the ADS, you can find all our multilingual pottery vocabularies. We developed these multilingual vocabularies in different European languages, for example, Italian, Catalan, Spanish, French, German, Portuguese, Dutch. And these catalogs are open data into this portal. Also, all the 3D models that were created from 2D drawings are open data into these catalogs. All the videos made during the project, but also the neural network, the software created during the project, is open source through our catalogs. So everyone can download this kind of data and reuse them as he or she wants. This is like an example of the data related to the models. For example, we have a Dressel 20 amphora, and you can navigate the model directly into the portal through 3D Hope developed by CNR, but you can also download the 3D model or the SVG profile, and you can reuse as you want. This is the metrics of this archive with all the visits and download. And the numbers are very interesting. From December 2018, we have a very high number of visits and downloads of this archive. So this kind of data can be useful for archaeological community and can be reused as you want. But, and this is the last thing I want to show you, you have, as I said before, you have also the possibility to share your data, the data you collect by yourself using the app Archive with the archaeological community, with other researchers. Because the Archive application gives you the possibility to store your data, your pod share, your images into the application store. You can put your data into your site, for example, the site of your archaeological excavation, and you can include them into subcategories. For example, each stratigraphic unit, each context can be added into your site. In this way, you have two different possibilities. You can share all your site as open data. So all the data you collected during your excavation, all the pod share you photographed during your excavation and for which you have a recognition can be shared as open data. But if you want, you can also share only one pod share. So the image and all the data related to the recognition of that particular type. And also this can be disseminated as open data. We decided to give the choice, the responsibility to every user. We discussed a lot because at first some of us want an open by default policy. If you use our application that is for free and that is open, you have also to open your data. Anyway, we decided to make education in this sense, and so to invite people to publish their data. I don't know if this could be the right way. Anyway, only with a larger comprehension of the importance of open data, we can have so many and useful open data open and share with all the community. So at the end, we decided that this was a responsibility of each archaeologist. So I finished my presentation. Thank you very much for your attention. And if there are any questions, I'm here for answering you.
Thank you, Gabriele. That was quite fascinatingly complex scenario that you described, and the copyright is always a little bit scary. If you have questions for Gabriele, you can use the Facebook comments or the YouTube comments, and there is also a Telegram channel that I think has been showed before on screen. If not, I believe it will appear shortly. And we have, in the meantime, a few questions already for Gabriele. We can start with, I see this one from Paolo Rosati that is asking which is the service used to view the 3D model of amphoras and pottery in the archive?
Is 3D Hope, the software created by CNR EAST. We use the new version that was released a few months ago.
Great, thanks. Got more for you. Does Arcade app learn from user input, for example, images and feedback match found? The newly created dataset, crowd-based, is available for download and reuse. This question was from Julian.
As the first part of the question, we do not use immediately the data coming from the user. We discussed this a lot with our colleague in Tel Aviv, and this is not possible because we haven't enough real data, because for training this algorithm, we used synthetic data, and we use real data only for the testing. So we need that these data are clean, are the right one. So the process is not directly, does not go directly from the user to the neural network, but it could go indirectly. So we can check if all the data taken by the user are correct, and then we can use them for retraining the algorithm, but not immediately. Because the possibility of mistakes is too big in this case, given the numbers of images. For training the neural network related to shirts, we used only 3,000 and 3,500 images. They were used only for the testing. For training, we break artificial object for having millions of shares. So this was the reason. As for the second, the data are available only if the user decided to share them, as I illustrated at the end of the presentation. This is an open responsibility by each user.
Right. Thank you, Gabriele. We got another question from Andreas Puls. I apologize in advance for all the names that I'm gonna mispronounce, including, the name of Arcade. Is it planned to cover? Is Arcade planning to cover other categories of artifacts or finds other than pottery?
Yes, it could be made. We discussed this a lot. For example, it could be made with bones, with coins. And now we are building a cost action for exploring all of these other kind of findings that can be recognized through artificial intelligence.
I think we may have time for one more question. I see that they're coming in. In the meantime, I will ask you a quick question if I can. I was really interested in this sort of mixed model, in this interaction that you described between free and paid content. I was wondering if you have any evidence that the open content somehow works as a promotion for related paid content. If the paid content is sold more because there is a free context available.
We discussed with this expert, with a distributor, not a publisher, that is an Italian distributor, because they, from my point of view, correctly saw a kind of business in this way. I agree with you, it's a kind of promotion. You can have all the information about paper catalog that maybe were printed 30 or 20 years ago, and they are now out of the market, so they have no more value. So you can sell for few cents information, or you can send new information, new paper, and using the old paper catalog for promotion. I think the second way could be more interesting for them, given the material open and having the opportunity for selling new material in a purchase.
Right, thank you. And I think the last question is indeed coming. Okay, it's from Arjuna Cecchetti. What is the role of the digger who finds the fragment? Can the digger upload his or her impression on the fragment?
Yes, if it is possible to share just 1 moment my screen, I can show this. Anyway, if it is not possible, okay. If you can see, in the case of on the left, you have all the data related to one pod share, and in the field notes you can add everything you want. So your impression. So you can say, okay, this is this kind of decoration from Montelupo, but it was not so typical because of this or that, and so on and so forth. And you can also add the particularity of the context and whatever you want. So in this case, you can add all the information you think are interesting, not only for you, but for other users.
Right. Thank you very much, Gabriele. If you have any more questions for Gabriele, you can ask him maybe during our virtual bar, where there would be, time and opportunity to chat with the other participants and with all the speakers. So thanks a lot, Gabriele, and you'll find Gabriele this afternoon as well. I think is the chair for the afternoon. And let's move on to our next speaker, that is Benjamin Duque. And Benjamin is the head of scientific computing at the German Archaeological Institute, and is here to talk about, one of the biggest and most established projects for digital archaeology. That is, actually a bit of an umbrella project that includes a lot of smaller, very interesting projects that interact with themselves. That is the IDA world. So thank you, Benjamin. The floor is yours.
Okay, thanks for having me. The presentation is visible now, I take it? Screen sharing works? Okay.
Yes.
Great. So I'm going to talk about EDI World, or IDI World, which is an open source research data infrastructure. And I'm not going to talk so much about technologies today, but I thought I'd give you some insight and knowledge about how to maintain and sustain an open data infrastructure over a large time period. Now, granted, the German Archaeological Institute is a little bit special when it comes to resources. It's a rather old archaeological institution. We have recently had our 190th anniversary. The Archaeological Institute, the German Archaeological Institute, is not a university institute. It's part of the Federal Foreign Office of Germany, and it has been part of the Federal Foreign Office for as long as that office has existed now. So today we have 20 office locations all across the world. We have about 300 to 400 regular staff. 2/3 of them are on a full-time permanent basis. During excavation seasons, the number of people that work for us, of course, goes up dramatically by several hundred more at least. Our current annual budget is around 30 to 40 million euros. And we, of course, the German Archaeological Institute, having been around for such a long time, We have large archives of traditional archaeological excavation data, some of it representing some of the oldest archaeological research data in the world, and some of it representing absolutely recent top-notch modern research data. So we don't only have archaeologists working for us. Of course, we have a natural science department, we have architects, we have engineers, surveyors, etc., etc. So you can imagine there is a lot of data, a lot of different categories of data to take care of. I'm not going to go so much into the details here. It would take far too long, but the response to this has been to build an online infrastructure that is really meant for well-structured research data. So it's not a simple repository. It's these are database systems with structured data, and it's a bit of an effort actually to produce quality data to go into that infrastructure. Some of the systems are a little more demanding than others. They are all a little bit individual because they have a very diversified history. I'm just going to yeah. So, but the essential idea is that it is all about the data. It's an absolutely data-centric approach. We don't really care about applications so much. Now, to be clear, the German Archaeological Institute, we do not actively support or closed or proprietary source software at this point. All of our in-house training, all software development is open source. But we also do not put any restrictions on our researchers. So if somebody uses proprietary software, they will use proprietary software. The important thing is that at the end of the day, our data infrastructure can support the research data. So just to give you an idea about some of the modules in the infrastructure, I'm not going to go into the details again because you can just do that yourself. It's all online. The software is in the GitHub repositories. You can take a look around. Just to give you an idea, our oldest component is the Arachne or objects database. That has been around for more than 20 years now. And it has 3 or 4 million research records. It's a big database, a classical relational DBMS architecture. The Gazetteer is, I think, it's a complete in-house development. It's an authoritative register of ancient places with a hierarchical data model and based on web frameworks. The GeoServer is one of our newer components. That's really an online GIS, which supports all of the OGC data standards. And here we have just used a very complex stack of free and open source GIS technologies that was already around and just adapted that a little bit to our needs. And then finally, this IDI field, there's going to be a workshop. There's a workshop in the program for later this afternoon on our field client. This is actually our only in-house client development. So it's an offline component to take into the field, install onto your desktop computer for primary field data capture and management. Here's just a quick visual impression. This is our classic Arachne relational database. It's very heavy on images, very heavy on linked data as well. The Gazetteer looks like a kind of Google Maps for archaeology, and that was more or less exactly the idea. The GeoServer, which is an online web GIS and geodata repository, uses all the standard OGC technologies, so it can connect with web feature services, web mapping services, etc. And this is a quick impression of some of the screens of our field client. Okay, now when I first got into open source software, there was still a lot of a debate about if you should be an open source fundamentalist, and there was a lot of ideology around about open source. So today I think we're at the point where this idealistic free software movement, I mean, it still exists. I still find it very inspiring, but in practice it simply doesn't matter anymore. But what matters is the open source idea. Open source is a term coined by the Open Source Initiative, exactly because they wanted to drop all of this idealism and get down to business. Yeah? So there is no contradiction between open source and commercial software. This is extremely important to understand. A software like QGIS, LibreOffice, Firefox, they all have business models. Red Hat is a big company. Microsoft has an open source business model. Yeah. There's a lot of money being made with open source software. There's in fact so much money that even a company like Microsoft has to seriously think about how to get into the open source market, because otherwise they would really miss out. The real contradiction is between open and closed software. So the question is whether for your money you actually get to own software and participate in software development, or you just get a binary that you can run and that's it. That's the real important difference. And even if open source development is non-commercial, like it is in our case, the DRE is not allowed to make any profits. It's a public institution. But it still costs money. It costs a lot of money. Software development time is very, very expensive. And the market for software developers is very tense. There's a lot more demand than there are developers available. So we have to pay good money for them. Yeah. Just to give you an idea of what we spend year on year for software development internally, I think it roundabout comes to almost €1 million if you consider the entire ecosystem per year. If you also include things like systems administration, project supervision, etc., etc. So it's expensive, and that means that any project that wants to survive in the long term has to have a good, sustainable plan. Yeah, there's a really interesting study. I don't know if all of you are aware of it. That was already published in 2011 on some of the largest open source GIS projects that were in existence at the time. And if you compare these, the graphs are really quite interesting, especially for GVSIG, which was a development funded by the municipality of Valencia in Spain with a lot of money and a lot of developers. You can see this year, 2008, that's the financial crisis. Yeah? That's when the banks go down and the business model of the municipality of Valencia goes down and development goes down. And today, GVSIG is a niche development. It has no relevance compared to QGIS any longer. QGIS has a slower growing but a lot more sustainable model. They also have a lot of sponsors in Switzerland and South Germany, for example. They do not have as large investments as GVSIG used to have, but more steady and more long-term. And it works exceedingly well for them. In fact, I made this little comparison in 2014 of all of the open source GIS projects that were still around back then. You can see there's a striking difference in the smallest and the largest projects. Some of them have a much larger code base than others. But size isn't really the most important aspect here, because if you look at the situation just 6 years later, you see that some of the smaller ones have been all but eliminated, but some of the larger ones as well. So obviously, some of these have sustainable models and others do not. Yeah, consolidation is a really hard thing in the software market. It happens really fast. And no matter how well your intentions are, it can kill you anytime if you don't really have a good sustainable model and strategy. So the problem is that in software development, we always have conflicting aims. And I've just put a few of them on this slide that we have encountered over and over again when we plan software and develop software at the DRE. So you have to understand that the problem is if you optimize for one of these, for example, for cost or functionality, you're going to sacrifice on other points. You can't have all of these at the same time. It's mathematically proven that within a closed system, you can only optimize for one parameter. Yeah. So that is a balancing act we have to do all the time. It's not easy at all. I mean, ask yourself where you would put your priorities, yeah, to really be able and grow and develop in the long term. So I'm going to give you a few recommendations that I feel are really very important. And these are not technical at all, and it doesn't matter what sort of software we're talking about here, what sort of development environment. These are really general lessons that I think we have learned over the last 10 years or so at the DAE, what is really important for long-term software development. The first thing, and I think this also came through a little bit in Gabriele's presentation a moment earlier, you have to get the politics out of the way first. You have to clarify the copyrights and license issues. You have to look for competing interest in the group of people that you're working with. You have to make sure that everybody is on board. If somebody is dissatisfied, it's not worth going to the next stage unless that is absolutely clear. You're going to have a minefield to deal with later if you don't get all of this out of the way first. Yeah. Then you identify all of the non-technological issues. So you're going to get a lot of feature requests. I would like the software to do this. I would like the software to do that. And you look at it and you say, first you try to identify those issues where you say, yeah, you can do that already. We don't need to create new software for that. Just modify your workflow a little bit, or maybe just train your staff a little bit better on the software that exists, and we can avoid having to create new software for that. That is really, really important as well, to avoid dead ends and bloated and too overly expensive software developments. Then you have to prioritize synergies. I know it's hard, you know, we all love programming, we love to create our own software. It's our own little babies, you know, and but there are other babies that are just much better and smarter than ours. That's the problem. Yeah. so you really have to look, are there perhaps projects already that do what I want to do, or partially do what I want to do? Could I integrate here? Yeah. If you manage to attach your development to a very sustainable open source project, that's really your best strategy for long-term survival. Yeah. Do not overplan. That is something our programmers tell us all the time. You know, don't spend months discussing, you know, feature plans and use cases, etc., because we will never manage to start working if you keep planning all the time. And that is a really big problem in the academic environment. Yeah. People have their heads full of ideas. They have all of these great plans. The project applications have been written, of course, with hundreds of pages full of ideas that need to be implemented. But you have to get started at some point, because only when you get started will you be able to find out which of these plans are actually realistic at all and which are not. Yeah. So we have had all these different models, development models at the DAE over the last decades. We have had these very classical models where we had like a years-long planning period, and we have these very modern models, agile development, where you work with no plan whatsoever. Yeah. And I think we have really learned our lessons from that you should also not underplan. Yeah. So the problem, of course, is that when you work in an environment like a public institution, but I think it's also true to a certain degree when you work in a company environment in software development, there are certain organizational and financial targets that you have to hit. Yeah, you have a budget for a year, for example. You have a plan. You have a project application. The project application, it promises certain things, certain needs that have to be covered with your development, and you are also obligated to write a report at the end of the year. Yeah, to justify the spending, especially in the Archaeological Institute, where we have spending from the ministry. We are under extremely tough budget constraints, and we need to justify our spending all the time. So if we, for example, outsource work to external companies, we cannot say, okay, we need money for 1,000 working hours for agile software development. That's not going to work. We're not going to get that money. We need to do it the absolutely traditional way. We have to state the development goals that we want to have funded. We have to state the value of these development goals. We have to state how we are going to make sure that these development goals are met. So that's like working in the 1980s from that point of view. Yeah, and we really have to find a balance between these two aspects of over planning and under planning. That is one of the most difficult things actually to get right during a live, you know, when software development goes live. This is one advice that I would give anybody who plans to write a complex software, complex program, first try to outsource complexity. What I mean by this is that we all know how easy it is to write really complex software that neither somebody else nor we ourselves will understand in a few months from now. Yeah? Program logics can tend to get really, really very complex, and it can get very difficult to understand and modify complex programs with complex program logics. So if you can, you should try to outsource complexity, and complexity just exists. You cannot always just get rid of it, into other aspects. For example, relational database models, even if they are very large and you have a lot of links between tables, etc., etc., a relational data model is still something inherently simple. It's relatively easy to understand, much easier to understand than a very complex program code with a lot of complex logics. So trying to outsource complexity, I think, is a good idea for software development. And then finally, this is something that is exceedingly important, and this is one of the aspects of the Agile software development and Agile manifesto with which I simply do not agree. I do not think that writing software is more important than documenting software, not in the long term. Yeah, I think that you need to document your work at all levels, including the program code. When I write software, the relation between code and comments is at least 1-to-1, at least one line of comment per one line of programming code. Often it's more like 2 or 3 lines of comment per one line of program code. I know it's also a question of age, actually. When you're younger, you tend to write more code and less comments, and you tend to produce code much faster. The older you get, the more you think before you do something. That's just a matter of aging. You can see this in almost every programmer. As they get older, they produce less lines of code. They take much longer to produce that code. But when it's done, and it works, and it's well documented. There's almost a little bit of a culture clash between younger and older programmers. But I find documentation extremely important if you want to produce something that is sustainable and that someone will be able to pick up again 10 years from now. And still be able to work with. So in the program code itself, the APIs need to be documented. There needs to be a sort of meta documentation that explains how your program works, so everything fits together. There needs to be a user level documentation, etc., etc. And I think that the relation in software development, you have a relation of about 2-to-1. 2/3 of your time you spend documenting, bug fixing, brainstorming, discussing, etc., and about 1/3 of the time is invested into creating actual code. That's the sort of time relations that certainly are true for my work. Yeah. I don't know how it is with others. Maybe you can give me some ideas how it is in your cases. But so finally, always keep in mind that you work with people, not with machines. Yeah. So I don't know if you know Conway's law. That really summarizes it in just one sentence. This is the problem that most larger organizations, at least, that produce software struggle with all the time. Conway says that an organization that designs a system, defined broadly, so instead of system, just say software. An organization that designs software will produce software whose structure is a copy of the organization's communication structure. And instead of communication structure, you can also say hierarchy, traditions, beliefs, etc., practice. Yeah. So that is something really important to keep in mind. The environment in which you work has a certain culture. It has a certain way of doing things. Yeah. And you're not going to change that easily with software, even though you know that if you could change it, you would produce much, much better software. But you're still not going to be able to. And if you think I'm wrong, wait 5 or 10 years, and then you'll understand that Conway is right. Okay. All right. Thank you.
Thanks a lot, Benjamin. Your very matter of fact experience and advice. It's very precious. I'm a big fan of the work that you've done at the IDI. I have a request from the people that are listening, Benjamin, if you can join the Telegram chat later, because they have more questions for you. But we can also pass a couple for you right now. So one is from Julian, and he's asking if you are planning to accept and host datasets from thirds that are willing to deposit their data, or these are, specifically the AI-oriented tool. I understand I can fork and use tools.
Yeah. So these questions are not easy to answer because the IDA world is so complex. We have all these different modules in it. Have you? Okay, I'm going to put this in the public comments maybe. Oh, I can't. Okay. If I just screen share one more time, because I forgot to show you the very last slide here. Yeah, you see the URL here, idai.world. Yeah, that wrong screen share. Sorry. You don't need all of that. So yeah. That's the URL for our portal page now, because we realized that we have so many different modules, it's almost impossible for anybody to understand what all of this is about. So we tried to create a new internet portal where you can you find all of our projects, and you find a bridge into all of these different systems. So for example, if we talk about the GeoServer, IDAI GeoServer, that's one of the most approachable components, I think, of our infrastructure. There you can basically just upload and download data in standard GIS formats like shapefiles, geotiffs, etc., etc. Most of the other backends, because they are so strongly structured, they have some sort of an import front end, that you can use to import, upload data sets. Of course, the entire infrastructure is also open externally to anybody. You will have to get an account. We do not have a single sign-on technology for all of our systems yet. So you're going to have to visit these different systems that you're interested in and create your account on these pages. We do have an open data policy at the DRI, and we try to really motivate all of our projects to produce open data under Creative Commons licenses, but we have no means of forcing people to do that. So we also have more strictly copyrighted material. You will find, if this is the case, you will find the copyright notes, etc., in the dataset descriptions, and there's always a way to contact the site administrators if you're interested in data that is under a more strict copyright. This is a very complex issue. Gabriele also touched on it, but this is an issue that we constantly have to be aware of. Copyright management, license management, it's constant work behind the scenes all the time.
Right. Thank you, Benjamin. And one more for everyone who wants to join the public Telegram chat. The link is on the ArcheoFOSS webpage. And we have one more question from Paolo Rosati that wants to ask you if and how the community of archaeologists can contribute to the platform. I know there will be a workshop today afternoon, but not all the community will participate. So maybe if you can give us
all of our projects is on GitHub, are on GitHub. They're all on GitHub. I think that especially the field client maybe is a project that might be attractive to look into. I mean, if you're familiar with GitHub, you can just fork. I think, I don't know if that is what it's called on GitHub. There are so many different repositories, but yeah, and then you can try to get your code back into mainstream as with any other open source project. But if you would like to cooperate on a project base, of course, we are always open to that as well. Why not?
Right.
Yeah, you can contact me if you like.
Be careful what you say, Benjamin. Okay, I think this is possibly our last question for this paper. It comes from Andrea that is asking a technical question. What open spatial formats did you choose?
Yeah. So like I said, so the gazetteer is something, this register of archaeological sites, that's something a little bit special. That's a very custom-made application that was developed before there were actually any good online open source GIS solutions around. Yeah. So that uses its own representation of sites in JSON format, but it does have an export to shapefiles as well. Yeah. The GeoServer, which is just really an online GIS system, which is based on GeoNode. GeoNode is a fantastic open source project if you want to build your own online open source web GIS. That supports anything that normally is supported by open source GIS. I mean, shapefiles, geopackages, whatever you can, for example, also use in QGIS. Plus, you can connect with a software like QGIS directly to the server using these OGC protocols like Web Feature Service, Web Mapping Service, etc.
Okay. Thank you once more, Benjamin. I think that we need to move on to our next paper. Our next paper is about the CITR project, and the paper is by a group of people that I'm going to shortly introduce. And the first is Mirella Ser Lorenzi, who doesn't need a lot of introduction, so I'm going to say just a couple of things about her. That she was from 2000 to 2006 the archaeologist director at the Soprintendenza per i Beni Archeologici di Ostia, and she's currently archaeologist at the Soprintendenza Speciale Archeologia, Belle Arti e Paesaggio di Roma. The other people that authored this paper were Riccardo Montalbano, that is adjunct professor of ancient topography, landscape analysis, and GIS at the International Telematic University Uni Nettuno. Ascanio D'Andrea, who works for archaeological conservation projects in Italy and abroad. And last, Carlo Cifarelli, who is one of the CITR project software engineer and the system administrator. And I believe that we have Mirella presenting, and Mirella only is you speaking for the paper? Okay. So thank you very much, Mirella, that is going to talk about CITR, a new open data infrastructure for a public archaeology of Rome. And I think there will be a demo presentation as well. Am I correct?
Sì, buongiorno, provvedo subito a mettere il PowerPoint e iniziamo. Condiviso?
Sì, grazie.
Dear colleague, it is always a great pleasure to take part in this annual meeting and to share with you the gradual development of CITR project. As most of you already know, CITR, the Archaeological Information System of Rome, has been well known to the ArcheoFOSS community since its very first design phases, which date back to 2007. As you can see in this slide, in that year we began a long process, still ongoing, that led the Superintendenza for Archaeological Heritage of Rome to be at the forefront of this innovative project, born in a fruitful climate within the ministry. The main purpose was to meet the practical needs to management, protection, and promotion of the archaeological heritage, and to respond in an effective way to issues related to city planning, without leaving out the scientific purposes and the desire to open, for the first time, the archaeological knowledge of Rome to the community as a whole. Today, I'm not here to retrace the many and often tiring stage of the project, already well known to the community. You can easily read the list of our main goals directly on the slide, but rather to highlight an aspect already underlined. In the demo about the state of health of ArcheoFOSS projects. I am referring to the longevity of the CITA project, which not only still exists, but is now relaunching. In fact, it is important to reflect on the financial commitment that a public administration must support in strategic projects that gain strength only if conceived in the long term, especially in a reality as that of the city of Rome, where the impact of archaeology on the contemporary city is a very strong one, and it grows with its changes. The reflection should extend to what could be meaning today of a solitary experience in the face of the possibility of John large already existing pilot project, like I spoken to Benjamin Duca. It is now clear to everyone that a long-running project needs to have collaboration of all kinds in order to renew and strengthen themselves. This is why CITAR, all along this year, has never renounced to sign agreements with the 8 profile partners, such as GAR for infrastructure, long-last strategies, CNR, and the university for SciDoc CRM of University of Verona, and Ariadne for semantic issue. I'm sure that today's event, albeit in this anomalous digital version, will provide an opportunity to share interesting ideas with the entire community. It's with great pleasure today that we inaugurate the latest IT developments brought to completion. And it's not a coincidence that it happens right within ArcheoFOSS community. Thanks to the latter, the platform provides users with an increasingly powerful infrastructure, renewed tools and service new data. The objective from the very beginning is to allow all users, both academical and general public, to have direct access to the immense documentary heritage of the Soprintendenza. In other words, it is more and more important within the framework of the project to transform it into an open data and interoperable platform, but which also has collaborative tools in itself, thanks to which users at various levels can interact dynamically with the database. Also, in this perspective, we offer renewed solution today, as you will see in the demo that will be presented at the end of the session. CITAR platform application represent a first set of media tools through which the Soprintendenza is gradually reformulating its institutional role with respect of the past, now being able to undertake, to implement, and to guarantee new information service dedicated to the public archaeology of Rome and its urban landscape, in compliance with full standard accessibility and appropriate validity dataset formats for all users. Although there is still a long way to go and there are still many challenges ahead, today we can say that we have managed to stand up to those goals we set for ourselves many years ago. Thanks to, above all, the ability of a continuous renew. In this regard, together with the new platform, we also announce the new official website that will be available Monday, full of tutorial and notes for use in order to facilitate WebGIS navigation. I am glad to leave the floor to Ascanio and Andrea, who will go deeply into the heart of the matter, describe the latest design phase and, above all, highlighting how complex systems such as the sitter need continuous regeneration and structure elasticity in order to evolve toward increasing advanced technology. Thank you.
Thank you, Mirella. In the meantime, we welcome also Ascanio and Riccardo to the presentation.
Thank you, Mirella. Thank you, Valeria. I will share the screen. Hope you can see.
I'm sure it's coming.
Okay.
There it is.
Okay. So good morning, everybody. This first slide, as Mirella already said, CR project is a long life project in 2007. So what we are calling a new open data infrastructure. The main switch between the old one platform and the new one, it's towards the relations between the system and the users. So we try to analyze and understand which kind of user are using the CR project, and we try to adapt the system towards this user experience. So trying to create an on-demand system that can switch different services for different tools and user experience. The four main characteristics of this on-demand system could be summarized as follow. It could be for sure the scalability, because each component of the system we can dynamic size depending on the real needs of the moment and in midterm and long-term strategies. We try to increase the performance. When you experience a WebGIS application, always you have to maybe wait for the server response. So we try to create a system that can distribute the resources and that can increase the user experience. We are talking in milliseconds of waiting for refreshing pages. These allow also good maintenance because we can quickly make intervention, focus on the real issues of each component that can create an issue. And last but not least, obviously the interoperability. The system is based on data independent platform, independent from the technology we use, and we will look deeply how to manage this. We would like to highlight how to maintain and create a sustainable project, as we heard before in the other presentation. The main three pillars in such a kind of project could be summarized as data, the IT, and obviously the community, the user. Each component of this structure is important. So the sustainability should be underlined when you, the strength that we have to put in the project is to keep alive all of these three components at the same time, with the same strength, with the same quality, such as the IT in this case, but also for the data qualities or data structure availability, and also the user experience. So only with the strength of continuity towards the sustainability, we can follow and can enhance the project towards long-term strategies. We try to learn this reach by the things that we have done in the last years. So for sure, the financial sector that received the project is very important, but not only. The management strategies is where very bespoke and focus on the real needs. Things that we want to underline is this such a kind of big projects is also an opportunity for the professional growth of the team that works together inside the project, but also outside with the user sharing user experience. This creates such a data responsibility. This is very important because once you feel owner of your data, you can care about this, also if you are not inside the project. And last but not least, the clear focus on open data services in order to create this as a relation between outside and inside. We'll go deeply inside the system. I will talk just an overview about the data. Mostly we will talk about the IT infrastructure and the communities tool, the user tools that we provide. As we already know, CITAR was presented in different publication and workshops. I just want to highlight that it's a complex database that in 2016 was analyzed from a logical point of view, a conceptual point of view, and logical point of view, and published in this publication that it is available on the website, so you can read deeply how is the structure of the database. I just want to highlight the main entities, relations inside this data structure. We have four main, we can summarize four main entities: the origin of information, that is the area in which something archaeological happens, and all the partition related to this origin information. So we are talking about all the layers that components archaeological investigation. The archaeological unit, that is the phase of interpretation of this data. And the law constraints of fraud protection, that is very important component from an administrative point of view. At the center, we create a new component that is this user area. We will look later how we can use it. It's related to the how people can interact with data depending on the area of interest. From IT point of view, the logical infrastructure can be summarized in this like this schema. We have on the right the server side, and on the left the client side. At the center, we have this Zool proxy that can manage this access control. It can, as I mentioned before, that can distribute the resources depending on which will be the request from the client. Going deeply, the spatial data is organized with a GeoServer, as we have heard from the IDAI project, a Postgre and SQL and PostGIS extension databases, and this component, the MapTiles cache, that can create randomly caches needed to increase the performance of the WebGIS application. Also in this case, the Zool proxies works as a wall and a distribution for the resources. For the attributes and the documents inside the database, we use this fantastic open source project that is Elasticsearch, with these components, the Kibana, the dashboard to manage the infrastructure, and the Logstash component and the crawler component that can index all the files and all the documents with the OCR technology. Also in the case, the Zool proxy managed how to distribute single requests, multiple requests, RESTful requests, etc. And the last part, but not least, the client and how the client talks with the server. We use the REST API architecture, and in order to manage single calls from outside application, but also from inside through the WebGIS client. We have just two short video here. This is the new interface of the project CITAR with all the data, and you can easily manage all the layers, base maps, and switch on, switch off, query the data, etc. Level maps with all the information that are stored inside. And the same thing you can do searching inside the digital library with over 200,000 documents stored inside, and the data, the results is presented organized in different version depending on what you are looking for. The last part regarding the data is the new open data services that the platform provides through a channel HTTPS. The client can ask for a content negotiation and receive back JSON form, a JSON file, GeoJSON, ATOM, so standard formats that can easily be managed inside his own project. This is very the base of these services are, for example, the download tools that is very easily. You can choose the area that of your interest. Just click the button for download, choose the format, and download your files. And you can open and manage and use as you want. Another more complex features for the open data service is calling the platform through the REST-ful architecture. This is very powerful. So we have the URL to call the request headers with the formats and the encoding for the entities, so the origin information, the partition, etc., for all the documentation, or also for the OCR data. The request body that organize all the data, and I just highlight this incredible and very powerful word that normally in SQL you have like, equal to, etc. This fantastic operator that is should. Your research should produce a result. This is very powerful inside the Elasticsearch. And we can see some example after. And the request body that the server gives to you. It gives the ranking to your search, so you can have your response organized in a hierarchy with the height scores results on the top of your search. The last, for the spatial data services, you can call the GeoServer from your own GIS client. For example, here in QGIS, just calling a layer of your interest, and you can add to simply add to your map and query and ask for information and create your own GIS using CITAR data. Going to the last part, so the stakeholders, the community around the CITAR, we try to summarize here the four main groups. So we have a public user, professional user, the GIS expert, or the developers that can use this RESTful API. And you can read all the different user has different services. In this case, we think about the CITAR databases as a circular process to produce, obviously, to be served by knowledge, participation, communication, and obviously it's an urban archaeological project for a shared urban planning. The public user mainly what can do? He can obviously customize the map layers, navigate, search the content, print maps according to the needed format, download freely, as we have seen, collect and organize data in its own library, can report an issue, and can record. These are two tools that we provide, and I will describe. For example, he can request for such a document that is not freely accessible, and just put a request and ask to download, because for a research purpose or something like this. He will get the confirmation for his documents, and will get the file. I'll just go quickly because we don't have so much time. You can see more in detail during the demo sessions. The same thing you can do for requests for change. If you find an issue or a problem for that is the location, some kind of data, you can submit a report regarding that specific data, the specific archaeological features, and we will receive this report and can exchange and interact with you, trying to adapt this new information that arrived to the system. The other part is for the professional users group. We create these user areas. It means that overlapping the user areas with the original information, we can create a special join. So getting all the attributes that are included inside these user areas. This allows us to create an automatic special join querying inside the PostGIS, get the documents related for each of this investigation, and assign these rights and privilege to these documents, depending not only on the user, but on the area of incidence. This is summarizing the web application in your dashboard with your documents, in which you can download and interact with it. This means that also if a student have to study a certain part of Rome, we can create an area of interest for the student and allow him to interact with the documents for this area. Further challenges. We are in 2020 with this new release. Next steps will be we will concentrate on archaeological potential and risk assessment tools using the data stored inside the CIDR database, and trying also to find a way to visualize all this huge amount of data in the 3D framework. We are thinking in mid and long-term strategy, so who knows what will happen. I just want to thank all the team, and you can see all the guys in this slide and in the new website that will be online during today, I think. Thank you.
Thank you, Ascanio. Thank you, Mirella and Riccardo. This looks like an excitingly sophisticated project, and I invite everyone to have a look at the platform that should be live from today or Monday. Today. Okay.
Today, sorry.
Today, perfect. So congratulations for the launch, and you should be able. You probably have seen the link before, and it's probably going to be on screen again, but the address would be exactly this one: repository.archeocitorproject.it. We were planning to have a demo, but that is not possible because we are really running behind, and we're already basically eating up the break time. But you can have a look at the demo on your own if you follow this other link that you should be able to see on screen again. Thank you again to all the speakers that presented in this first part of the second day of ArcheoFOSS. And just a reminder that all the videos remain available on YouTube, so if you missed something, you can catch up. And you can ask questions to our speaker through the Facebook page, through the YouTube link, and also on the Telegram chat that is an open group, and you can find the link on the ArcheoFOSS page as well. We have, okay, someone managed to sneak in a question, and it is from Pier Giovanna Grossi. Apologize if I missed something. When data will be online? I'm not finding the data license on the website. Can you please link it? Or maybe you can just quickly answer.
Yes, sorry. Data will be online today, so you can follow the link, and you can get all the data license type in the website. There are a specific section you will have. It's not online today, but today will be.
Wonderful, thank you. I'm afraid we don't have time for any more questions. I'm being a little bit cruel here. And we can take, some almost 15 minutes break, so we can, grab an actual coffee and pretend we are all together. And we will be back at 10 past 11 for the paper on sparkling by Sophie Schmidt and Florian Thierry. In the meantime, I think you can also visit the virtual bar. I believe you find all the useful links on the ArcheoFOSS page, and I'll see you all, I hope, in about 15 minutes. Thank you all again.
Thanks to you, Valeria.
Okay.
Hello, everyone. Welcome back to the second part of this second day of ArcheoFOSS. Just very quick reminders that if you have questions for the speakers, you can use the Facebook live event, you can use the YouTube comments, and you can also use the Telegram open group. And you'll find the link in the ArcheoFOSS page. If you missed any of our great presentations before or yesterday, they are all archived on the ArcheoFOSS website, and you find them on YouTube as well. But now, without further ado, we can start introducing our next paper. And our speakers are Sophie Schmidt, who is a prehistorian and computational archaeologist that is now working at the University of Bonn and the Cologne Digital Archaeology Lab, and Florian Thierry, who is a geodesist and a research software engineer, and is the founder of the Research Squirrel Engineers Working Group, which is also the topic of the paper that Florian and Sophie are presenting. And I have to say, it is one of the most active, interesting, and bubbling working groups related to computational archaeology. So thank you for joining us. And I think, Sophie, you should unmute yourself, and the floor is yours.
I'm not unmuted yet. Okay. I'm unmuted, right? No? Yes, perfect. So thank you very much for these kind words and introductions. I'll see the screen sharing works, and I just go to presentation mode here. Okay, cool. So sparkling Ogham. In this talk, we want to talk about our side project in which we digitize an analog catalog on Ogham stones and link it with existing databases on the web, thereby creating linked open data. This is Florian and I, and we were introduced already, so just a quick correction. I'm now already working on the German Archaeological Institute. You see, things are moving quickly in the archaeological world with the jobs and places where you are. And we are, as research squirrels, as a small, just hobbyist working group, are interested in open science, linked data, and in Ogham. So what is Ogham, and what are these weird signs on our slides? Ogham is a script that was inspired by Latin, but was developed for the Proto and early Irish language in the probably 4th century AD. It relies on strokes that are carved on the edges of stones, as can be seen on the photo on the right-hand side. The angle of the strokes and the length of these strokes determine their phonetic value. And the script is being read from the left to the right along this edge of the stone. The stones were erected during the 4th and 6th century AD, mostly in Ireland, but there are also some found in Wales, England, on the Isle of Man, and very few are found in Scotland. On them, mostly names and tribal or familiar affiliations were recorded. And they were deciphered using the Ogham writings and manuscript, which date to a later date, and a few of the English stones are inscribed in Latin and in Ogham. On the Ogham stones themselves, only two categories of words are being used: formula words and nomenclature words. Examples of formula words are maki, which means son, or mukoi, which means tribe or sept. Formula words thereby describe relations between people. And the nomenclature words or names or name parts are, for example, kuna, which means wolf or hound, or katu, meaning battle, and some names refer to possibly divine ancestors, such as Luke, and they tell us about the society and the values of the early Irish people. The combination of the formula and nomenclature words leads to inscriptions that feature kinship or tribal relations. What the stones were used for is still under debate. It may be that familiar affiliations and tribal relations became much more important during these times, and there was a need to commemorate them repeatedly. Maybe these stones were used as cenotaphs, maybe they were used to mark territory. As most of them have not been found in situ, but repurposed in later buildings, the interpretations vary. A few inscriptions as examples, they usually follow a kind of formula, something like X maki Y, so X being the son of Y, or X maki mukoi Y, X is the son of the tribe Y. So examples are son of Dal, son of Fergusus, son of the tribe of Toika, or Kunalegi, descendant of Knakanos, or the son of the tribe Kopagnus Klassikonas. And as you can see, not always the actual person is being named, but always a relation is being named. So these relations are forming networks. And a network is easily modeled as a graph, meaning a person is a node and the relation to a different person is an edge. And as we are here at a FOSS conference, we now want to focus on how to model such networks in a free and open source way. One free and open source way to model graphs as resources on the World Wide Web is RDF and linked open data. RDF is the resource description framework, which is a family of World Wide Web consortia specifications originally designed as a metadata data model. Databases and their entries can be modeled as simple sentences in triple relations. A triple relation is a relation between a subject and an object which is determined by a predicate. Linked data takes this approach and uses it for publishing data by interlinking different datasets as resources around the World Wide Web. The principles of the linked data are quite simple. Every dataset has an URI and HTTP access, so it can be found on the World Wide Web. It then can link to another resource on the web which has an RDF model, and thereby information what kind of link exists. And thereby we can link different kinds of data, creating this linked data cloud. Archaeological data is very context relevant. So we believe that archaeological data should be part of the linked data cloud, as the context information can be stored quite often in different databases. And a researcher looking for archaeological data quite often doesn't find it all in one database, but in different ones. And it's much more easier to find all the different informations if these are linked to each other. Now, as you probably know, every database that's created is usually created offline first. And quite a lot of projects use advanced databases by now, but most of them are only offline. Very few of them are online. And of those few that are online, even less are online and open. By open, we mean they've got an API and the context, the data is downloadable. And of those that are online and open, even less are part of the linked open data cloud, meaning they link to other datasets. If I'm now should I be an Irish archaeologist and would like to look at all the Irish Ogham stones, there are of course different resources I could use. There are loads of publications, and the most important one is the Corpus Inscriptionum Insularum Celticarum by McAllister, published in 1945 and 1949. And of course, different publications can be used that are offline. Online, there is, for example, the CISP database by the UCL, which collected a lot of different inscriptions, not just in Ogham, and the database is online now for almost 20 years. It's online, but it's not open because it doesn't have an API, and you can only click through the different entries, which is good for a database of that age, I have to add. And we are very thankful that we have this database. And then another resource you could use that is actually online and open is the 3D OGAM project, which digitizes three OGAM stones in the University College Cork corridor, where you can see the first photo. It's the largest collection of OGAM stones in one place. And they digitize them as 3D models and give relevant information as well. And then there's also the heritage management, WebGIS of Ireland, where a lot of different data sets are provided, which you can actually download and use. All these are online and open, but they are not linked to each other. And now I give over to Florian, and I hope he can unmute himself.
Hello, everybody. Can you hear me? Hopefully.
Yes, we can, Florian.
Perfect. Yeah, my internet connection is a bit unstable, so it just came back right now. So I hope it will work. So thank you, Sophie. And yeah, so what's about linked OGAM? And as you know, there are several possibilities to host this modeled and published linked open data with, but they are causing major challenges. So first, it's data modeling. Second, it's data publication. And third, it's the community building. Next slide, please. Yeah, and how can we model and publish this OGAM data? Maybe we can use a well-known community-based systems, for instance, Wikidata, or another one, we can create our own ontology to formulate a triple creation process and host the triple store with a Sparkle endpoint. And yeah, as I said, we could use Wikidata, and hopefully all of you know Wikidata. If not, I will, have a short introduction into Wikidata in this slide. So Wikidata is a free and open knowledge base where everybody can add and edit new data. It's a central storage for structured data of Wikimedia projects. And if you enter data into Wikidata, the data is available under a free license. It's public domain. It's multilingual. It's accessible to humans and machines in a graphical user interface, an API, and Sparkle. It's exportable using standard formats like JSON, RDF, and XML, and it's interlinked to other open data sets on the linked open data cloud.
Okay, I think we may have lost Florian's audio. Sophie, do you feel like taking over?
It won't be as in-depth as when Florian did, but okay. So what we did for Wikidata is we used the information collected in McAllister's book from 1945 and collected information on the stones, on townlands, like where were they located, the material, dimensions, inscriptions. And we linked especially the townland information to existing information on the web, OSM data, which is locational data. And after linking those, we inputted into Wikidata and were able to link it there to already existing data sets. From Wikidata, you or everyone now can extract this enriched data with the help of the Sparkle Unicorn, which is a project I think Florian and Timo will also describe in another session in this conference. And after extracting the data, it's of course open for further analysis with other software. We use QGIS and R. The Wikidata import was done via OpenRefine and Quick Statements. And here's some screenshots Florian did during this process. And the modeling of the OGAM stone in Wikidata has these kind of information. So we modeled the instance of the OGAM stone by itself. We modeled it as a part of the OGAM project, which is our project here. We modeled the location as the country Ireland. We modeled the coordinate location, which was derived from the Ogham site, the location of discovery, which is county and Ogham site. We modeled the inscriptions, the material used, to which collection the stone belongs, and length, width, height, state of conservation, and usually added an image if we had one. So here are some examples, or it's one example, the stone CIIC, which is the 4th stone in the stone corridor of the University College Cork. So it's an instant of Ogham stone. It's part of the Ogham project. We have got the coordinate location, what kind of material was used. Okay, it's a stone. This one, we didn't have more information. And to which collection it belongs. The location of the discovery and the height. So the inscription was modeled as well. And we also added which formula words the inscription mentions. So here Maki and Mukoi. If you go to this Ogham link to our project website or go to Wikidata and extract the view, you can see the number of Ogham stones we already modeled and just map them on a map. The second way to model the Ogham stones, and now I'm really not into my waters anymore, we could use Protégé and RDF4J, meaning we model the data in our own ontology and in a triple store. This workflow is more or less the same in a way, but not quite. So we still extracted the information in the beginning, put it into the CSV and transformed the data into RDF format and put it into the RDF4J triple store. Afterwards, we can still extract the data and continue our analysis with it. The ontology can be created using base vocabularies from different kinds. So OWL, CDOC-CRM, Friend of a Friend, GeoSparkle, SCOS, or Pleiades are already existing ontologies which can be used to create one that fits our kind of data best. And here is one modeling which Florian did, and which is just the first, I think, idea we had about how to do this. Afterwards, the CSV is put into RDF via Python. So we defined a triple creating process in an open source way. Afterwards, you can use a triple store for publishing the data and in Sparkle endpoint to take it out of the dataset again, like to query it. So what are the pros and the cons of those two approaches? One pro is of using an own ontology is, of course, you develop your own flexible data model. The data model you have really fits to your data. A pro is also that you have a data sovereignty, so nobody is going to change it. It's and you have full access to your own triple store, and you can put it on a publication server. The cons are you have to develop your own ontology, which is a bit of work. You may have data sovereignty, but there is no interaction with less well-versed community members. So if someone doesn't really, is not knowledgeable about how this works, there's just no way people will add data or will improve upon your data. And if you have to, if you use this way, you have to have your own publication server, and this may cost some data. You want to have it in a sustainable way. So this is all things you have to think about. If you use Wikidata,
if you want to take over, if I want to take over,
you're back.
Okay,
Great.
I'm back. So you're at Wikidata, right?
The pros and cons. Yeah, please continue.
Yeah. So if you use Wikidata, you can embed. You are directly embedded into the linked Open Data Cloud. There is an active community and citizen science, and the publication of linked open data plus the Wikidata APIs and tools are available. But there are also a not so flexible structure. You have no data sovereignty, and yeah, all special tools have to be developed. So next slide, please. To summarize, somehow, what are the next steps with the Occam stones? Next slide. There is a big project from the German Wikimedia Foundation, the fellow program Free Knowledge, which the Occam Stones is part of, and I will produce in the next a month very nice, cool things. So next slide. Then we can do, for sure, geospatial analysis as well as statistical analysis using R or whatever. And next slide, please. If you are interested in the topic of linked open data, there's another big community. It's the CAA. And there we founded this year the a special interest group on semantics and layout in archaeology, where we would like to further establish linked data in archaeology, enable beginners to use and produce linked data, invite other scientists for discussion, and embed linked open data as an important topic through an SIG at the CAA conference and community. So if you want to join us, just Google the Data Dragons at CAA and feel free to contact us. And
Oh no. Yeah, so I just I'm left to say thank you, everyone. Do you have any questions? I hope I can answer them. And of course, we have got a little bit of literature and our credits. The slides are actually on Zenodo already, and you can cite them. Thank you.
Thank you, Sophie, and thank you, Florian, if you're watching us on YouTube. You can maybe join the Telegram chat, so if people can ask Florian questions directly. But we have Sophie here now, so we can definitely ask her questions. And by the way, thank you, Sophie, for taking over without even blinking. I may start. I really liked the fact that you showed us, I believe, a completely open workflow. You have used all open tools, and I was very much interested in the comparison. And talking about Wikipedia, you mentioned citizen science, which is something I'm very interested in. Have you thought of developing this side, maybe contacting museums or interest groups?
We have only contacted some people that already have ORGAM databases, such as the old CISP project, which actually gave us their database, which is and to insert in Wikidata as well, but didn't want to talk about this here. But we haven't contacted really museums. Actually, on Twitter, someone just joined us saying, "Hey, I've got some data on Scottish Occam stones, and we want to continue working together." So yeah, I think there are probably quite some possibilities, but this is a kind of side project, and we didn't want to. We wanted to finish one kind of big chunk of data first before going to other institutions and asking for their data. Yeah.
Great, thank you. So if anyone else that is listening has, data about Occam stones, please get in touch. If we don't have any more questions coming, then because we are running again a little bit behind, we can move to our next paper. So thank you again, Sophie and Florian, and we can go to another group paper that is Digital Editions of Objects and Classes, the Conspectus as an online system of relations and references. And this paper is presented has been authored by 4 researchers. And again, apologies in advance for any mispronunciation of names and surnames. Katja Rosler, Frederick Hout, Wenke Domscheit, and Kerstin Hoffmann, which I believe are all part of the RGK Frankfurt. And I think that our presenter is Katja. So the floor is yours, Katja. Tell us everything about the conspectus.
Okay, thank you very much. Can you hear me?
Yes, we hear you fine.
Okay, thank you. So I'm going to share my screen and I hope it works. Let's see. Can you see it?
Not yet, but I'm confident it's coming up in a moment. Yes, there it is.
Yes, it is. Okay, thank you very much. So I'm going to refer back to the talk of Benjamin Ducke a little bit because the RGK belongs to the DAI. And I'm as well not going to talk so much about technique or software or workflows, but more about data and content. So thank you very much for giving us the opportunity to present our work today here at the ArcheoFOSS conference. I'm going to talk about the transfer and the transformation of already published data. In the coming 20 minutes or so, I will first give you a short introduction to our project NOAA and its background. Then I will explain what kind of data we are dealing with through the example of the conspectus. And finally, I will introduce an app that allows a specific access to the conspectus data, the archaeological form slider. In a project of the Central Scientific Services, the commissions, departments, branches, and research facilities of the German Archaeological Institute, DAI, are currently working together on a user-oriented module built around forms and shapes of archaeological objects. It will be added to the existing tools and services of the EDAI world, you see here. The form or shape of an object is one of the most important analytical features for all archaeologies. So, under the name of EDAI Shapes, the DAI aims to create a collection of data and thesauri to offer workflow guidelines for 3D digitalizations of archaeological objects and to test automated processes for the recognition of forms. We at the Römisch-Germanische Kommission RGK in Frankfurt are collecting and digitizing data of object shapes. NOAA, Norm Data for Objects in Archaeology, is a sub-project to the DAI Research Data Project. It is led by Kerstin Hoffmann, Deputy Director of the RGK. The project members are Wenke Domscheit, an archaeologist who worked for the Portable Antiquity Scheme, Frederick Hout, an archaeologist and software engineer, and myself, an archaeologist who is specialized in methods and theories of classification. Also, David Wick-Wolf, who has vast experience with digital data and online databases in the area of numismatics, consults and supports the project. The RGK was founded almost 120 years ago. Its main purpose was to bring together and institutionalize researchers interested in the beginnings of Central European history that at the time were mainly organized in associations and learned societies. The RGK was and still is primarily a central coordination body for archaeological research. It conducts excavations and surveys, oftentimes in cooperation with other institutions. It is a conference venue and meeting point. It houses an editorial office and an extensive library, as well as an archive consisting of scientific estates, correspondences, and protocols. Certainly, these functions and its organization define the data it is hosting. The data consists not only of primary data, but of descriptive and analytical data, be it archived on index cards stored in cardboard boxes on the left, be it presented in the scientific publications you see on the right. One specific form of publication of archaeological objects are catalogs, atlases, and corpora. Kerstin Hoffmann introduced the term Ding-Editionen, editions of things, for these kinds of publications. They present the data in lists, short catalog texts, and plates. Furthermore, they oftentimes supplement or even replace the examination of the archaeological finds. Edition of Things are powerful instruments that up till today are shaping the representational style and the language for archaeological objects, be it their names or their formal description. One edition of Things that is widely accepted and is continuously used is the Conspectus Formarum Terrae Sigillate Italico Modo Confecto in the following just Conspectus. It is an edition of objects that is of plain Samian ware produced in the 1st century BC and in the 2 centuries AD. The Conspectus was compiled in the years between 1986 and 1990 by leading specialists for Samian ware, all of them members of the learned society Rei Criterii Romani Forturis. The aim was to overcome the usual geographically bounded classifications that are based on the analysis of production sites, context, or chronology. Instead, they have tried to systematize that knowledge in such a way that future researchers will find it helpful as a framework within which to arrange their own perceptions and on which to hang future accretions of knowledge. An open and future-oriented framework is a defining component of digital databases, but the data were not recorded in a database, although the technical possibilities were already at hand in the discipline. Hence, other than being an edition of primary object data, the Conspectus is a revision of prior classes and a synthesis of prior classifications. It is an edition of classes. Since the Conspectus is a publication of the RGK, the whole correspondence between the authors and the protocols of the workshops held to discuss the concept of the classification and representation have been stored in our archive. And through these documents, we have a deeper insight into specific knowledge production preceding the publication of the Conspectus. Here you see a few examples of the workshop protocols, and in the center you see a proposal on the numeration of the types of K, who is the author Philip Kenrick, while W, who is the author Colin Wells, replies by saying that he doesn't like the dash. To us, the representation is very informative, because it shows the subdivision of defined forms into subforms and the existing relations between them indicated by lines. Our analysis of these archived records will be published online subsequently to the release of the online database. Fortunately, due to the standardized catalog and representation of the Conspectus forms by standardized drawings, it is very easy to transfer the object data into a relational database. In doing so, we strip away the data from the context of the book pages, insert it into spreadsheets, and finally convert it to a relational database and generate the proper SQL commands. One dataset consists of the numeral designation, the production site, the place of discovery or excavation, and literature references of the actual objects belonging to the form, plus a concordance to other classifications and possible additive data like the form of the rim, the wall, or the bottom. What's more, in the catalog text, one finds descriptive relations, often in very short sentences, more like special mentions. And they are not as straightforward as one might wish for. They are descriptive, and some are more tangible, like cups of form 22 are being produced and used alongside plates of form 12, but others are very vague. For example, a few recorded instances of this form suggest that it is a hybrid of forms 12 and 18, or the form evolves gradually into form 20. So these descriptive relations are now in our database. And by representing every form through its own dataset in the database, all the descriptive relations become displayable. This reopens the data to queries concerning the production, function, find context, and chronology, but also to the more vague relations of possible hybridity or the like. Furthermore, the datasets will be linked to external resources and services of the IDA world, to the portable antiquity schemes, to other online available publications like the work of Dragendorf, to the databases of Roman coins, and, of course, to databases of stamps like the Corpus Vasorum Aretinorum, a database which we are currently transferring into an online version as well. Hence, the data is more easily available for further archaeological studies of objects. The online database, available soon under the given address, is a transformed edition of things. It is not a sole digital reproduction, but a new revised edition of the book, because we erased errors and inconsistencies. It is enriched with easily accessible information. And the data are transferred into another data medium, and therefore the user will be handling the data in different ways. It is virtual now. This thought led us to develop a different kind of access to the data in addition to the standard UI of the database. Let me just add that the UI of the Conspectus database is currently in development, and I'm very unhappy that I'm not able to present it to you today. But what I can present to you today is a different context for the data we created. Just in case you might have asked yourself in the meantime what the Conspectus classification actually is, the following will answer the question. In the recent weeks, we developed an app called Archaeological Form Slider, or in short, ArcheoFOSS. Inspired by Antlitz Ninja, an app that allows the combination of different parts of portraits and the well-known slider puzzles for children, we wanted to transfer the effects of these games into the handling of the Conspectus drawings. These games encourage the precise observation of features by enabling individual production of pictures. The user might perceive characteristics he did not perceive while studying the whole picture. Furthermore, these games make the not or not yet existing a subject of consideration. As it is common in archaeology, the standardized drawings in the Conspectus depict on the left side the drawing of the profile and on the right side the reconstruction of the exterior of the vessel. We have cut these drawings accordingly to the vessel's components, rim, wall, and bottom, and deleted the reconstruction on the right side. In the end, we have made available approximately 1,500 sliders. The app is built in the following way. On the left side, the users have access to the working space where they can change the sliders, move them, zoom in and out, and thus can create their own complete profile. On the right, the users have access to the catalog of forms. It's the catalog of the Conspectus. They can select the forms or the components of the vessel they like to work with. Through information buttons, they can enter the database at any time to gather information. By pressing the solution button, the reconstructed exteriors of the self-created vessels pop up, and the users immediately grasp if they have created an existing vessel or a camera. In addition, the users will see on the right side the forms they combined. So here you can see the app in action. In the beginning, a random selection of sliders is shown in the working space. The user can move the sliders via the pressed mouse button. Sliders can be changed via buttons and zoomed in and out via the mouse wheel until they seem to fit. So here he changes the rim, the user changes the rim. This seems to fit, a little bit of zooming, fitting. And if the user figures that he created an existing or interesting or just a very nice looking profile, he presses the solution button to see the reconstructed exteriors. In this case, he created a camera, but a possible one. So very briefly, let's come back to the classification of the objects in the Conspectus. Since it is a classification deliberately not on the basis of chronology, distribution, production, or function, it can only be a classification of shape characteristics. So the typological groups are in each case depicted by a vessel that is the best representative. Theoretically, the types are unambiguous, and for the highly standardized Samian where the objects might come close to definiteness. But the many subforms that had to be created by the authors, as I have indicated before by showing you the author's mind map, are revealing that the features are changing and that their determination takes place with a certain kind of vagueness. This is not explicitly mentioned by the authors in the publication, and it rarely is in the context of archaeological publications in general. Types almost always are presented as unambiguous. But as I mentioned before, in the case of the conspectus, we are able to verify the ambiguousness through the archive protocols. They disclose the discussions and compromises that have been made. So the archaeological form slider can catch up on the subject of the inconsistency of features and the vagueness in the determination of types. Let me finish with an outlook to the possibilities of the app we see. It could use drawings generated by the laser edit profiler, for example. The laser edit profiler is used in different projects on different artifacts and the DAE for the automated production of drawings of profiles, especially of shards. In addition, the app could use photographs. Hereby, other features like the surface finishing, the use of varnish, the color of the fired clay, and the manner of the tempering would be coming into consideration in the combination of sliders. Furthermore, the sliders could be tested with other objects than pottery. And finally, there may be connecting points to other applications. For example, the app IDA-Field, the field research documentation system of the DAE, which you get to know in the workshop today, already uses the conspectus forms to enable fast and easy access to data concerning the classification of objects during excavation and surveys. Here, the form slider could complement its service. Please note that the data of the conspectus will also be part of the module IDA shapes. I mentioned at the beginning, and Benjamin Ducke mentioned as well. There it will be retrievable in connection with the broad range of different data of archaeological objects. And it already is part of existing online databases and apps. So our database that is closely connected to the publication is just one way of approaching the data published in an edition of Things. Thank you very much.
Thanks a lot, Katja. This was a very, very rich and interesting project. I confess that I am itching for, going and playing with the Chimera bases now. Do we have questions coming? I think that our wonderful colleagues in the backstage might be gathering the questions, but I might start in the meantime. And I was wondering if you are considering, I know this is only one aspect of a very complex project and rich project that you described, but I was very fascinated by the vase building thing. Have you considered generating 3D files because you have basically a combination of fixed forms that could be relatively straightforward?
Yes, it would be possible. Why not? We are open to every try and every idea. Yes,
that'd be wonderful. I can already see, people making their own 3D printed collection of
wonderful
of possible bases.
Yes.
All right. I think we may have still a few minutes for questions if they come in. I don't see them yet, so I might sneak another one, and then maybe we'll just thank you and your colleagues. We have heard a few times mentions of copyright issues and barriers, and because your starting point was an existing publication, I was wondering if you have any first-hand experience to talk about when dealing with copyrighted material produced at different points in time.
Yeah, well, that was one of the reasons we started with the conspectus. Our project is just 1 year old, So we have still a few more years to go. But the conspectus is, people ask for the conspectus to use it. And so we know it is used and it is still valuable for research. So this is why we started, and make it open, make it approachable, make it linked and open with linked open data with other databases and other publications, to give it to the public, because we know there are copyright questions with it.
Yeah, that sounds like a very sensible approach. Thank you. And we have a question from Julian Bogdani that is asking if you are going to maintain the URIs to refer once they are online.
Yes, I think so, because we are in under the umbrella of the IDAI world. We're going to keep the URI.
Great, wonderful.
That's good for us.
Great, thank you, Katia, and thank you to all the collaborators to this paper. And I think we may be ready to move to our next paper. And our next paper takes us in a museum collection, and we're going to talk about a case study of data management of museum collections, and we will be talking about the Libertini collection that is kept at the Museum of Archaeology in the University of Catania. And our speakers today are going to talk on behalf of a large research group that I'm going to name. And the authors of the paper are Nicola Laneri, Rodolfo Brancato, Salvatore Cristofaro, Marianna Figuera, Marianna Nicolosi Asmundo, Daniele Francesco Santamaria, and Daria Spampinato. I think they are all in some ways affiliated with the University of Catania. Apologies if I'm wrong about that. And we have today three speakers from that great group. And we have Nicola, Marianna, and Daniele. I almost got it. Okay.
And we're a very big Sicilian extended family. That's why we're like, we are here to avoid connection problems and to be together. So we are here with our face mask and keeping a social distancing. Thank you, Valeria. So what we're gonna do today is basically, let's see, how do I start? ArcheoFOSS. ArcheoFOSS PPTX, sorry. Okay, perfect. Can you see do I have to start presentation? Okay.
Try that.
Can you see it?
Yeah, we see you.
Okay.
We see your slides as well. Okay,
perfect. So what we're gonna do today is presenting a small university collection that is based on an archaeological set of data from the prehistory until the medieval time in eastern Sicily. When I was appointed director of this museum in February, I started talking with colleagues at computer science and other young researchers within our department. And the plan was to start the process of digitalization of our collection that contains 350 objects. And the idea was to create something that would involve the students. So we created a framework based on distancing for the digitalization of all the objects with the help of our young researchers and people from computer science in order to create a new set, a new form of open source catalog using modern standards and working also on web ontologies. This is the idea behind this project. As you can see, we also created a short movie that is on our webpage, and we involve the students in telling us what they think about the collection. The collection, as I said, it's a collection that included a kind of a mixed match of objects collected by Libertini from 1920s all the way until the 50s. And so I'm here introducing, as director of the museum, the collection, but I will give the word to Mariana Figueira. This is one of our young researchers within the Museum of Archaeology that will talk in details about the digitalization. And finally, Daniele Santamaria will tackle on the web ontology issue related to the digitalization process.
Okay, thanks, Nicola. Now we will continue inside the project, saying first of all that the digitalization of the collection of the Museum of Archaeology explores innovative models of data entry in order to encourage not only new research by specialists, but also the discovery and interpretation of cultural heritage by a wider audience, including university students who have been directly involved in the process of data entry. All the finds will be made available and usable online in an open and connected format, following the spirit of a public, shared and participatory archaeology. The core of the museum is the 325 finds belonging to the collection that was donated by Libertini to the University of Catania in 1953. Archaeological collections may carry an impressive amount of data. Indeed, the Libertini collection consists of a wide range of archaeological materials such as pottery, coins, glasses, metals, inscription, and so on, and from different periods. The main part of the collection consists of finds from the Greek and Roman periods, that is, fine and common wares, epigraphs, terracotta figurines, coins, and so on, mostly unearthed in the archaeological sites of Catania and in the Centuripe area.
Mariana, sorry to interrupt you. Is it possible to show your slides full screen? We're seeing the left bar as well.
Ah, ok, sorry.
È successo qualcosa alla presentazione sotto quello.
There's nothing big. It's just, that we see the slides a little bit smaller and you're using, such nice pictures that it's a bit of a shame. But yeah, if you can't fix it, that it doesn't matter. Just keep on going.
I don't know why, because I...
yeah, no, it's all right. It might be just a compatibility. Compatibility issues. No worries.
Okay.
Sorry, I interrupted you. Please go on.
Okay. So we will continue. Okay. Among these are some noteworthy forgeries, that is 78 objects forged in the first half of the 20th century, which for the outstanding level of craftsmanship and the use of authentic molds deceived many archaeologists and art historians. Digital representation of archaeological data in open formats play a crucial role, not only in cultural heritage preservation, since it offers significant advantages in the dissemination, use, and comprehension of information stored in old reports, archives, collections, and museum catalogs, but also in research. Since the aim of the project is to define forms of long-term preservation of digital data associated with the sites and objects of cultural interest, we shall use the linked open data paradigm and, more specifically, the web ontology language, that standard language of representing web ontologies, which are digital tools designed for the definition, description, integration, and sharing of sources of many domains of knowledge. Such an approach adds a high level of expressiveness for the possibility of using automatic reasoning tools, which allow one to obtain a more complete and comprehensive, as well as more complex and efficient form of digital research. Ontologies in this sense are ways to put together data that are expression of the history of the territory, but that have been kept separated due to administrative or bureaucratic issues. Only connected data can be fully exploited, but they must first be suitably collected and digitalized.
Senti, scusi Mariana, però si vede solo l'esclusione sempre la stessa, mi sa che non in full screen non ti
Do you see now?
Yeah, we're seeing I think the slide with the museum and Libertini's portrait. Yeah.
I don't know why. Okay.
Yeah, it's acting up a little.
You can see this one with legacy data. Okay,
No.
perfect.
Yes.
Okay. So, just a moment. I don't know, the presentation is, where is the presentation? Okay. Sorry. Okay. Now, I'm sorry for this.
No worries.
Okay. So I can, okay, perfect. Digital representation of archaeological data in open formats for us means also to put inside the problem of the legacy data. Because the use of the legacy data for archaeological research is a theme which has been widely considered in archaeology in the last decade. The collection digitalization project started from the mapping of the available legacy data, useful archaeographic data on the objects belonging to the museum, is dispersed in all published study reports and research papers in university historical archive, as you can see here, such as institutional correspondence of museum directors or the first inventory, old photos, and so on. And the recently published scientific catalog that you can see here on the left. Therefore, the decision to publish online the content of the Libertini collection, related with the quality of the finds, is possible thanks to the consistency of the supporting documentation. The project aims not only at reconstructing the history of the collection, but also at transforming it into a digital dimension through the processing, recovery, and republication of the available legacy data. The project will allow one to identify the context of scattered items and to relate the copy of the item with the original by means of an appropriate mapping of the ontology with the RDF Pleiades vocabulary according to the LOD paradigm. The digitalization started from the identification of the entities which characterize the core of the museum collection. So the domain has been conceptualized through a formal representation of all relevant entities and their relationships. The ER diagram realized is based on the prerequisites of completeness, correctness, readability, and minimality. The fulcrum, as you can see here, is the find entity, while all the other entities are organized into three main functional data categories: the topography in light blue, the characteristics in violet, and the documentation in yellow. Starting from the conceptual model obtained, the system was partly implemented with the addition for each entity of the information to be detailed. The logical model developed is organized into a system that adapts the ICCD standards with a view to a forthcoming integration with the CJAP web, beyond the usual information such as you can see here, the chronology, dimensions, materials, discovery areas, analysis, and so on. A specific attention was paid to the documentation, highlighting the importance of the legacy data. And moreover, we also did entities for comparisons and for keywords. The data management has been entrusted to a relational DB using MySQL, and for the development of an effective and expressive ontological model, the data acquired through museum resources have been normalized and organized into homogeneous and structured collections with adequately refined level of granularity. Some specific terminological vocabularies of reference have been determined, and others are under construction. The project is still in progress. All the data regarding the 325 archaeological finds have been digitalized and managed into the DB using a temporary web interface, waiting for the final web portal that will collect all the data regarding all the museums of the University of Catania. Now I pass the word to Daniele Santamaria. We will talk about the ontologies.
Non la fare, cerca di metterla così se ce la fai.
Hello, good morning. Just just a second.
Sure, Daniela, if you could manage to actually show the slides, because I'm afraid that we didn't see the slides moving while Marianna was speaking. So maybe I would ask if you can make available the slides after the presentation. I think that a lot of people would be actually happy to see them.
Okay. I don't know what are you seeing this moment.
You see the museum. Guarda, vedi qua, guarda.
Legacy data.
Okay.
I'm seeing from hard copy archiving to semantic web right now.
Okay.
Sounds the right one.
Thank you very much. So, as Marianna explained before, the task of acquiring and sharing data is, of course, one important step. But databases are, of course, well-assessed tools with a lot of interesting features, but if you are interested in advanced applications, databases may not be sufficient, mainly because they are built on fixed schema, and fixed schema cannot be combined together or cannot be combined with schema from other sources. So the semantic web is a great help in this sense. But before showing the project of our ontology, we need to I hope you can see the next slide. I'm not sure about it.
Yes, we can. Thank you.
Okay. So I need to briefly explain how semantic web works. We are very familiar with the concept of surfing the web. So basically, we land on a page, we see the content of the page, we process the content of the page, we find a link, and we click on this link in order to access another page. So the process going on this way. Of course, is maybe the most easy thing to do when we are looking for some information, but softwares and machines are not able to process the content of the page, or at least without the introduction of very complex and very expensive software, machines are not able to understand the content of web pages. So semantic web helps us in this sense. How does it work? Basically, can you see my pointer? Maybe not.
Yes, Daniele, thank you.
Okay, perfect. In semantic web, we have no pages. We have just entities. An entity is a digital representation of a thing. For example, if you have a bunch of coins, each coin is represented by an entity. Okay, so entities are connected each others by means of links, also called predicates. So in this manner, you can build a very large spider web, a very large graph connecting all the entities of our domain. So you do not navigate through pages, but through entities. So it's maybe it's a complex concept to understand, but in practice it's very easy also to implement. So, for example, if you have a bunch of coins, as I said before, you have an entity for each coin, and for the concept of coin, for the ideal concept of coin, you have an additional entity called concept, which identifies all the idea of a coin. Okay, so if you are looking for all the coins emitted in a specific period, you can submit a Sparkle query and you can find the answer. I don't know if this concept is clear, and if you have a question, please stop me. So, how semantic web can help the project of the Archaeological Museum of Catania? The standard procedure consists in building an ontology for a specific domain, and to put together all the ontologies. Okay, so when you put together ontologies, your knowledge bases increases, I can say, horizontally. So because your data is different in type. Okay, when you add data on a specific ontology, your knowledge base increases vertically because you are adding data of the same type. So the project of the Archaeological Museum of Catania is just the task of merging ontologies for different topics. Currently, we are merging two specific ontology. The ontoceramic, which is an ontology for the catalogation, the classification of potteries, and the epiond, which is an ontology for the classification of the epigraphs. And you can find the ontologies and all the references down the slide. What is ontoceramic? Ontoceramic has been designed on the Italian Institute of Catalogue and Documentation. Models very interesting features of pottery, such as ceramic glasses, type, dough, chronological periods of production, and so on. Currently, we have a lot of data populating the ontology, most coming from the archives of heritage superintendents of Syracuse and Catania, and the Regional Technical Office of Sicily, and the State Archive of Palermo and Catania. Of course, our ontologies are entirely mapped into the SIDOC ontologies. I can show you just a general schema of ontoceramic. I saw that there is a question. Is there a question?
Yeah, don't worry. We'll ask questions at the end. Daniela, go on with the paper. Thank you.
It just took my attention. Okay. So as you can see here, the most important entity of ontoceramic is the archaeological find, which is mapped into the entity A21 man-made object. So if you, for example, have a coin probably is a man-made object. So you can put your data concerning coins inside our ontology, just mapping them into the two man-made object. And so our ontology increases, as I said before, horizontally, because we have data of different types. So on the ceramic maps, a lot of features such as the shape of the find, the archaeological type, dimensions, conservation state, functionality of the object, decoration, depth, and so on. So we have a lot of information inside our ontology. As you can see in the next slide, if I can go on. Okay, we are also mapping a lot of pottery type, and each type is detailed described. So if you want to find, if you automatically compute the type of your find, you just describe your find and the ontologists do all the work for you. Okay, Epiont is an ontology concerning epigraphs. It models a lot of information such as fragments composing an epigraph, copies, type of inscription, the support of epigraph, and so on. Actually, it contains, I think that this data is not updated. I think that now there are more than 600 epigraphs inside the collection. I'm not sure about it. It extends the Eagle ontology, and of course is entirely mapped into the SIDOC conceptual reference model. I just want to show you a brief description, okay, of the Epiont ontologies. So, as I said before, we can map entirely the support of the epigraph, the fragments composing it, the motivation which the motivation for the realization of the epigraph, detail concerning the surface, and so on. Again, we have a detailed description of how the epigraph has been realized. So we have the motivation, the location of coming, chronological data, and so on. Okay, I just waiting. I just checking the streaming to be sure that you are seeing the same thing we see. Okay, perfect. Now, Epiont models also the support of the epigraph. We have a lot of information, such as the dimensions, the current collocation of the epigraph, the composition of the surface, the material used, and so on. I have just a small example of an epigraph right here. This is a very interesting epigraph because this epigraph is broken into two fragments. You see an inscription on the back of the epigraph and also on the top. So it's a very complex epigraph, you know. And epigraphs such as this one are entirely mapped inside the Epiont ontology. For example, as you can see here, we model the epigraph support, which has a surface representing the back surface of the epigraph, and another surface So the surface is composed of two parts, which describe the two fragments, and on the other side we have another cipher describing here the top. So very complex epigraph can be mapped inside our epi ontology. So the ontology of the Archaeological Museum of Catania is basically obtained by a standard procedure of combining and merging ontologies for different domains. Of course, other ontologies are coming. This is a work in progress, but a lot of ontologies probably will be added as soon as possible. So just some word about the project. As Marianne explained before.
I think we may be experiencing some issues with the audio of our presenters that luckily just managed to conclude their paper. Let's wait and see if they can come back to take our questions. If you have questions, as usual, you can ask them on Facebook, on YouTube, or on our Telegram group. If we don't manage to get them back online right now, maybe they can answer to your questions later. I take this time to remind you that we are about to conclude the first half of the second day of ArcheoFOSS. We're still hoping that our speakers will be able to come back, but in the meantime, just a few announcements. We are going to go on a lunch break soon, and the conference will be back at 2 o'clock Central European time. And we will start again. We will have Julian Bogdani opening the afternoon session. We would have asked our speakers this question. We hope that they'll be able to come back and answer live. So Julian is asking about the project that they just presented, if they are planning to actually go online, and if they did have any issues with the copyright of objects and archives. And copyright is definitely a theme that has emerged quite crucially today. And with what license will the data publish? And I truly hope that our friends from Catania managed to come back or to answer, because I think that was a very, very interesting case study, and I think they can definitely work as best practice for other museums. And I also wanted to thank in particular Daniele, because it was very brave trying to explain ontologies and semantic web in only a few minutes. That takes some courage. I'm afraid they won't be able to join us. Probably they had connection issues. So I would like to thank you everyone who joined us this morning. I hope to find many of you later today after our lunch break. If you have missed any presentation from this morning or from yesterday, they're all archived on the ArcheoFOSS page and on YouTube. If you have extra questions, you can always use our channels to ask them, and hopefully the speakers will be able to answer them. If we don't have any news from our speakers, I think that is all for this morning. Thank you again, and see you after our lunch break. We're going to be back at 2 o'clock Central European time. Thank you and goodbye.
Hello, hello everybody. Here we are for the afternoon conference. So the first presentation is by Julian Bogdani and is entitled Field Notes for the Development and Publication of Open Standards for the Vectorialization of Archaeological and Architectonic Topographic Legacy Data. Julian is a researcher at the University of Rome La Sapienza, and he works mainly with digital application in archaeology. So we are very curious of his presentation. Thank you very much, Julian. I give you the word.
Thank you, Gabriele. I'm sharing my screen and launching my presentation. Do you see that in full screen?
Yes.
Oh, thank you. So I'll try to share with you today some field notes, as I call them, because they are not a definite work, but it's something that we've been working in the last months and something that will work in the future, but feedback is very welcome. So just some field notes and reflections for the vectorization of archaeological and architectonic topographical legacy data. The structure of my talk, it's very linear, a very brief introduction at first of the PATHS project. That's important because all this works sourced by that project. Then an overview of this simple, the so-called simple vectorization protocol, why it was drafted, how does it work, and any possible future. And third, the most important thing to me is some methodological reflections and thoughts on the digitization and datafication process of the archaeological record and archives. Let's go through the first part, which is dedicated to PATHS. This is an ERC-funded project. The project leader is Paola Buzzi, and the project is located at Sapienza University of Rome. This is about the creation of an online atlas, catalog, and database for the representation of the geography of Coptic literary manuscript in Egypt, so between 3rd and 13th century AD. It's a pluridisciplinary project, but because it combines codicology, philology, archaeology, paleography, digital humanities, etc. But I don't want to spend too much time on this because you'll find a demo that brings you through the main aspects of this project. The most important thing is the map of the products. So the European Research Council calls them, but I prefer resources that we have created so far. By the way, the project is not finished yet. We have another 2 years of work, but the atlas is already available online. So what you can find actually on the web, it's our institutional portal, this one, the atlas itself, the online database that that contains all the important relational data that are behind the atlas and the entire information system. A documentation portal. Thank you, Benjamin, this morning for stressing out the importance of documentation. The documentation has for software development, but also information system development. I think I'm getting old, as you said, because for me it's the most important part of the entire process. Actually, we also have geographical data sources, like, for example, vector tiles providers, raster tiles providers, WMS services, WFS services, etc., etc. A large part of our information system lies on GitHub, on public repositories that you can go and share and download or fork, whatever. The atlas is there, the documentation portal is there, many data are there, and also many other smaller applications that we have been using inside our atlas, but also releasing for the broader community, lives in our GitHub repository. That's the URL, and you can go and check everything. Well, the philosophy behind of our work is that we had to build many resources and data sets from scratch or enhance previous available resources to be inserted into the To-Be Atlas. Well, each one of these published datasets has been made available by us with Creative Commons or Creative Commons-like licenses, and each newly created piece of software or library or whatever has been released with MIT licenses or similar. Single, I call them bricks, which are pieces of software or data sets, etc., have been published inside the Atlas, but also have been made available outside the Atlas as standalone libraries and software. And these bricks, these resources, have been fully documented in order to facilitate and encourage their usage and possibly improvement by you or by other persons that are looking for this kind of data. This is just a screenshot of our institutional portal. Another screenshot of the main Atlas. You'll find that the demo exhaustive, hopefully. And the screenshot of the main page of our documentation and data portal. And for those yesterday, they followed my workshop on Bradibus. This screenshot is familiar. This is the dashboard of the online database that we are using to publish all the data information about paths. This one, you find the URL in the lower part of the screen, is one of these bricks that I was talking about before. This is a road graph of Roman and late antique Egypt. This is a road network that links all sites that we are dealing with, and this has been released also as a standalone application. It's a single-page application. You can download and use, but you can also download and use the data behind it. It's like a Google Maps of antiquity. You can set, you can have directions for place A to place B and see how this place were linked during antiquity. This is another single-page application that pulls data from our main database service and displays in a very easy to comprehend map movement of manuscripts. In this case, it's called wandering manuscripts, because sometimes we know that a book has been crafted in a place, stored in another, have been archaeologically discovered in a third place. These places can be have been tracked inside our database, and since this information is available, it can be used to produce various kind of visualization. This is one of the possible ones. Special note relies on our data portal, where we are collecting various kind of data sets, all available for freely available with open licenses. We have up to 21 now. These are of different kinds, can be base cartography, vector data, data tables, RDF, whatever format. It's not important. You can find for each data set or each set of metadata describing them, and of course when available, you can find the URL when you can download or use them as a web service. Well, this is in brief the infrastructure of and the map of the resources that the PATH project has created up to now. I want to focus now on the main part of my speech. The part 2 is about the so-called simple vectorization protocol. What's that about? The problem that we dealt with was to provide, with an actual archaeological context, the atlas of the Coptic literature that we're going to build. The adapted solution was very simple. We had to recontextualize maps, topographical surveys, measured sketches, etc., available in literature or archive documents, etc. And the ITER was very simple. We had to digitize, vectorize, georeference, and finally vectorize, and finally, of course, publish online and made available. Well, we can consider this at reinventing the wheel. This is something that I believe any archaeologist does in this daily work. But let's go a little bit deeper in this process just to highlight what's the new thing that we are proposing here today. This is a very usual kind of graphical documentation. There's a map of a building. We don't know what, where, etc. But we have some metadata on that. We know that this is located in site with URN paths places 380. You can go on our atlas and resolve actually to actual coordinates and to an actual place, which has one and other toponyms. One of them is the Deir Mar Buktur, and this map was published in a book. The reference to this book is given by this string in here. This is the identifier inside our public Zotero bibliographic repository. You can go there, resolve, and you'll see this was published by Peter Grossman in page 165, figure B. Well, from the archaeological point of view, what can we say about these buildings? Well, different hutches, as we're used to, mean different phases. Usually we can track them phase 1, 2, 3, 0, which is chronology. But also we are used to see the different kind of lines, of strokes, line, or if it's reconstructed, this is usually rendered with a dashed line. Or also reference to the section plane. For example, we know that upper projections, structures that lay above the section line, are rendered usually as dotted lines, while structures laying below the section line are rendered with a continuous line. Also, we can easily see here doorways or other stuff like that. What is SVP about? SVP is about taking all these data and putting them in kind of sort of a database container, and also providing a very simple syntax for encoding all this time of all this kind of information into a very simple to use but yet strict manner, so that each operator can do several parts of the job and still have a common platform where to rely on. I'll just go through the main parts of these protocols, but you can read them online. You can also download some of our files that have already been published and go and study if you're interested to. But what we are encoding actually with SVP, we are encoding the reference, as I said, to the section lines. So we indicate with S, for example, the structures, the features that are cut by the section line, with U, which stands for upper, the features that lay above the section line, L for features that lay below, lower part. And we have an exception here. We encode with D, which is the only semantic interpretation of the function of the features. As you see, we don't encode function here, but just a reference to the section line. D is an exception that stands for doorways. Another thing that can be encoded is the state of preservation through the reconst key. We can say if a feature was preserved when it was surveyed and drafted, or if it was not preserved when it was rendered by the surveyor, but he didn't see actually the structure. We go beyond that, and we have introduced value 2 to indicate structures that were not surveyed by the original surveyor, but that we today can hypothetically reconstruct. So the operator, the man who does the job, can say, well, since I know this kind of building, I can say that there was a pillar here or something like that. So this is something new that was not available in the original draft of the drawing. Another thing that we can add is post-survey or post-publication state of preservation. Sometimes structures have been damaged, buried, or completely destroyed. So we give to the operator the possibility of indicating or marking up semantically this information into the drawing by setting lost to 0 or to 1. Of course, relative chronology can be easily encoded by using a numeric value. It's up to you what is the scale, the range of values that you use. Since our project is focused on late antique period, we mark with 0 the late antique phase, and we go with positive values to post main phase, and with negative values to previous phases. But it's up to you here, the implementation of the range. We can encode also, of course, information about the location, the name of the place and URN that you decide to what it resolves, or eventually a subplace, for example, Rome Colosseum. This Colosseum is the subplace, etc. We can also encode elevation data if we have them, height or an offset. This can be used, for example, to obtain automatically 2.5 dimension reconstruction. Other kind of metadata that are very useful are the scale of the original plan from which the vectorization is made, the source, as we saw before, the subsource, and the operator and date of the vectorization process. These are very useful when you go through validation, etc. How does it look like at the end of the day? Well, it's a GIS-based vectorization protocol, so it looks like features with attributes attached to it. The special thing is that the list of attributes and the values that you can use into them is fixed. This is the standard about. You can use that on the web, or you can use it in the desktop, and you can use it to also extrude features using height and quads and elevation, etc., and produce out of the box this kind of 2.5D reconstructions. And you can use different kind of maps to compose very complex plans for complex and multi-stratified sites like this. For each of these slides, and you can see below, you find an URL. All these data are available online, so you can go and play with this application and see in real time how they look. So to sum up, in brief, what can you do in SVP? You can mix sources of information, keeping track of each of them at a feature level, not at the building, not at the site level, but at the feature level, using, for example, source and subsource. This is most important. Add, of course, your own survey information, integrating legacy data. This permits you to update this kind of data. Keep track also of the evolution of the state of preservation of buildings or sites. Of course, reproduce the original survey semantics beyond style by encoding reference to the section plane, encode relative chronology, and encode elevation information that can be used in 2.5D reconstruction hypothesis. So in brief, you can encode geographical information with a very rich, yet this is most important, minimal and easy to implement set of metadata, which are project agnostic. This is also most important, and faithful to the original document, be it very rich and accurate in details or a very scanty sketch. Such data are very apt, from my point of view, to be archived and easily reused, remixed, and reshaped in different contexts. What can you do then? Well, you can extend this protocol by adding more attributes to encode project-specific data, for example. And you can actively contribute by sharing this documentation of yours about extensions and making them available to the broader community. To enhance also collaboration, we have also developed this validation tool, web-based validation tool, and you can copy and paste GeoJSON, and you get validation in real time, so you got a strict adhesion to the standard. So I'll spend the last few minutes of my talk on some methodological thoughts about digitization and datafication of the archaeological archive, and I'll use the metaphor of the looking glass and Alice going to and fro to explain my point of view to you and possibly have feedback for you. Well, the looking glass is the blue thing in here. In the upper part, we have the paper reel, and in the lower part, you have the data reel. Actually, when you do vectorization with CAD-based tools, all you obtain is analogic contact in a digital format. So you change the format, but the data that you're dealing with are fully analogic. You don't change, you don't introduce anything new. You just have the same thing that you have on paper on a digital format. It's just about format, not about substance. The same can be said for other vector programs like Adobe Illustrator, Inkscape, and whatever. All you obtain is analogical content. If you want to go through the mirror glass, you had to use, as you already, of course, know, GIS software that permits you to add to your vectors, to your features, attributes, database. This means you create what I call project-specific dataset, because it is you who are modeling your data to fit into your project. And from this, you can do analysis, of course, you can deal with data, we can share data, and of course, you can export this into an analogical content and use it, for example, into your publication. My proposal is to go a little bit deeper in abstraction and add a new layer, an SVP-like. I don't mean we all have to use SVP, but something like more abstract we need to use in order to create project-agnostic datasets, which can be potentially delivered as 5-star open data. And from each, then, it's very easy to create project-specific datasets and also archaeological analogic content in digital format. Well, the paper realm is the realm of illustration. The data realm is the realm where analysis is performed. This is human only, and the data realm, it is humans and machines realm. So there is integration, full integration. I see vectorization as a translation process of legacy, be them analog or digital analog data, into the digital, let's say, database-centric domain. Also, vectorization can be seen as datafication of the archaeological graphical record. And I think this is the most appropriate means to create open and linked archive. SVP is just an example, a tool to go beyond shape and deal with meanings. It is semantics. But of course, feel free to contribute, add your feedback, and let me know. I'm open to every kind of critics and contribution. Thank you, everybody.
Thank you very much, Julian, for your very interesting presentation. We have time for a few questions. One is already by Ricardo. Is there a kind of centralized validation process on the data processed by single operators?
Yes, as I said, we have this web-based tool when each operator at the end of this working day can upload its work and have a real-time validation of what is done and eventually correct some misspelling or use of abnormal values or keys, for example, yeah, in order to have a very strict implementation of the protocol.
Oh, okay. I appreciate very much your presentation. Everything was very interesting from my point of view, especially the part 3, because I strongly believe in what you have explained so well about digitization and datafication and the importance for archaeology to go to datafication instead of simply digitization of legacy data. And my dream is that in the next future, no more archaeologists will use CAD software, open or proprietary as they prefer, but no CAD software anymore.
They can use whatever they want. The point is, if they want to obtain data, it's not the best tool. If they want to obtain illustration, it's a very good tool. I mean, Adobe Illustrator or Inkscape are great tools for illustrations, not for data.
Yes. But from my point of view, archaeology is the field of analysis and not just illustration. Illustration are useful for analysis. That's my point of view. Anyway, thank you very much to Julian for his very interesting presentation. And now we have the next one by Andrea D'Andrea and Francesca Forte. Analisi e confronto di formati spaziali aperti e non aperti per la ricerca archeologica. Francesca is with us. Francesca.
Yes, can you hear me?
Yeah, we can. Is
Okay.
a PhD student at the Department Asia, Africa and Mediterranean dell'Università di Napoli L'Orientale. So thank you very much for being here, and we are very curious to hear your presentation.
Okay. I share my screen now. A moment. Okay. Can you see? No?
Not yet.
Okay. Can you see it? No?
Unfortunately, no. It's normal. Okay. Okay.
Now you see it?
Now
Okay.
it's online. Thank you.
You get it? Okay. So firstly, we want to thank the organization team for giving us the opportunity to participate to this conference. And we are happy to share the point of our research with all of you. So my speech wants to provide an overview of a current situation regarding the management of the spatial information and the tools that we have for their sharing in the archaeological field and in the perspective of open science and big data. So my speech will be divided in three sections. Initially, we will provide some indication, indication relating to the topic of open science, to the concept of geospatial big data, and
sorry, Francesca. Sorry.
Yes.
We see only the last slide of your PPT, but not the presentation.
Okay, so let me try with this.
Again,
Again,
your presentation.
Okay, like this,
that's perfect.
Can you see the second slide, for example, here? No?
No, you are on the last one.
On the last one? I don't know what kind of
you have
problem do I
to go back to the first one.
So, sorry. Technical problem. And like this?
Okay, perfect.
Okay,
Thank
so
you very
you see
much.
the second one now?
It's perfect.
Okay, sorry. Sorry for the inconvenience. So I was telling you that my speech will be divided in these three sections. One regarding the terms of open science, geospatial big data, and how they can be linked to the archaeological field. Later, we will deal with the topic of the data formats that are available online, both the open one and the not open one. And finally, we will show you a more practical experience of how is it possible to reuse data sets that are available online in a proprietary format, I mean not open one, and how it is possible to integrate them into your research through open system and web application, eventually for the need to manage the growing size of archaeological spatial data sets. So over the past few years, we have seen a diffusion of advanced technologies and the spread of the technology that is becoming more and more accessible each year. We have arrived to the production of a large amount of data. So in 2017, the Open Geospatial Consortium published a white paper to define more efficient approaches for the treatment of geospatial big data. So now what do we mean when we say geospatial data? What is the difference with geospatial big data? As you can see here in this slide, I put how can I say? I put how geospatial data are defined by the Collins English Dictionary. So information that are relative to the position of people and objects on the Earth's surface. With geospatial big data can be broadly defined as a data set that include locational information but that they exceed the capacity of widely available hardware, software, human resources, and requires a specialized effort to work with. So, applied research in the geospatial big data tends to be driven by the benefit of mining data to reveal the unknown spatial relationship and to discover, for example, new patterns and associations that otherwise would be difficult to discover. So how do we link the topic of geospatial big data and archaeology? Archaeology has long recognized that spatial location is a very important point in our field. We all know that spatial data, they are important for the reconstruction of the past, for example, to identify territorial patterns. And the technological advancement has affected even our field. Therefore, today we create, thanks even to the GIS system, we create, manage and share the archaeological data much more than before. But we have to underline that we cannot say that they are just spatial big data because the volume of the data we worked with, they do not exceed the available resources, let's say. However, we have to start to think that even if the volume of archaeological data is still under control, let's say it's still manageable, we have to begin as an embryomatic stage, as a first step that in our field, the big data is going to come. I mean, because data will for sure improve, will for sure increase in the future. So the debate on this issue is very active. Just think of the amount of data that, as you can see here, as I put in this slide, the debate is very hard because we have private organizations, we have that have excavation concessions, all the data by the preventive archaeology. So we have a lot of data that are going to come. So what the opportunity we have now is to shape the growing geospatial data set before it becomes too late. It can be done just by identifying the best practice for the creation, publication, and preservation of geospatial data through the use of standard format. What can this approach guarantee? As we see here, it can guarantee the reliability of data. It can be done a correct divulgation of our data and I don't know, the valid reuse, and for sure it can be guaranteed a long-term preservation of our data. The last decade has witnessed a proliferation of standards, and you have to think that today the Open Geospatial Consortium has 69 standard formats for the description of spatial data. There is a growing literature on this topic because we know the potential of using standard formats for the online publication of territorial database and the related geospatial analysis. They have been fully understood the potentiality, but there is not a specific guideline for orienting oneself among all these formats that may help to choose maybe one standard rather than another according to the need of anyone. So this makes the interoperability among spatial database very, very difficult and almost impossible to share with a broad variety of other data. So what we did was that we decided to analyze how the current scenario of archaeology responds to the process of standardizing the data formats that are available online for the spatial field, like repositories and geo portals, and how they can be integrated into archaeological research. Firstly, we examined the current state of art in Italy, and I want to underline that we examined the institutional experiences. An important point of homogeneization of the spatial scope of archaeological field came from the Ministry of Cultural Heritage with the emission of Circular number 30 of 2019, in which it is specified how the spatial data have to be represented in the documentation that have to be given at the end of excavation. The formats are limited, as we see, are the shapefile, the DXF, and the GeoPackage. We know that the shapefile is one of the most popular formats to represent the geographical data, the geographical feature. And even if it's not included in the OGC list, it is a format that is used a lot. And I mean it is used a lot, not just by archaeologists, but a lot of fields, they use a shapefile, but so it became a standard de facto. But I want to underline that shapefile is not a standard, it's a proprietary format. And DXF, it's a drawing exchange format for CAD drawings, and we can notice that among them, just the GeoPackage is a standard approved by OGC. So GeoPackage is a single file, it's almost new, it became a standard almost 5-6 years ago, and it's very good because it's a single file, and it's very good for information transfer. It's designed to store complex and voluminous data, and it is possible to store the style of the vectors. All this conferred documentation will then populate the National Geoportal for Archaeology. That is a project still ongoing, which will collect data that will be, let's say, partially structured. Because nevertheless, there are no information about the reuse of data. That is how the archaeologists can structure their data to make them completely interoperable. In terms of interoperability and reuse of data, so we decided to look for a free download spatial data set that could enrich the archaeological research, searching among the geoportal of Italian regions, and we realized that in most cases, as you see in this slide, the available spatial data set are in a non-open format. Usually they are in a shapefile, as we show you, you can see here. And this is the example of a geoportal of Regione Campania. And you have to, I want to underline that this choice greatly penalizes the possibility of enriching our research with a transparent, with a clear, with a structured data format through recognized standard. So we are guided in this study, in this research, by the awareness of that the archaeologists, above all for the non-hyper-technical side of archaeologists, they have to face some, let's call some problems when they have to do with spatial data. So we have some questions like, among all these standards that we have, which one could be the best one to use? How they are going to ensure the interoperability of data with others? And how these standard how can we shape our knowledge in the perspective of spatial big data, because they are coming. To try to find an answer based on a consolidated framework, looking at we decided to look at the important English experience that are the York Open Data that are run by the City of York and the Archaeology Data Service. In the last years, we know that they have represented a reference point for the archaeological field in terms of open data and public sharing of knowledge. The City of York has implemented, as you see, an infrastructure of open data and information about the City of York. There are a lot of downloadable data sets, from urban environment to education, up to archaeological data set. As you see here, this is a data set about archaeological documents. They are divided by geometry, and you can easily download them through 3 formats that are 3 non-proprietary formats. There are 3 open formats that are CSV, KML, and GeoJSON. You can download them easily without any legal restriction on their use, so you can reuse them in your research and easily read them and understand what information contains the data set just through a text editor. This is a screenshot of a text editor. It's very, very easy to understand what information contains the data. This is a prerogative of the open format to be clear, to be transparent, completely accessible, and this data so can be reused in anyone's research. The Cutting Edge ADS has updated in July 2020 a guideline for the description of for the depositors with a table that lists all the file types accepted, and we can notice that for GIS, the data that are accepted are or shapefile plus CSV or the GeoJSON file. So we noticed that there is a common thread that connects these experiences, identifiable in the GeoJSON format, and we have seen this point even in the speech of today, like the IDI experience, the CETR, and even what Julian just said before. So this GeoJSON format is widely used, and we know that it's not the most recent format, but it is very easy to process, and for sure, as you can see in this slide, it's a comparison of the file that with the shape file that is still most used. We have a GeoJSON that is open format based on a JavaScript object notation, so it's easier for the web application, for a browser-based web application to process. So it's widespread and supported by various software. As I said before, it's accessible by non-GIS software. Each data is encoded as an object to which is associated a set of name value. On the other side, we have a shapefile that is a proprietary format, it's a non-open format, and a standard only de facto. And you have to imagine that each shapefile we save is composed of several files. So we have one for geometry, one for coordinates reference system. So it will be very difficult to share. You have to remember every time to get with you all the files. The only, let's say, good thing, the advantage of shapefile is that it requires lesser disk space. So we have just seen the comparison, the advantages of and the disadvantages of these two formats. And so after we have been trying, this is a pipeline that we of an experiment we did, we have been trying to understand how a file GeoJSON could be created so that we could concretely verify the advantages of having a GeoJSON file instead of shapefile. This is the pipeline of what we did. We downloaded a dataset, uploaded it to QGIS, export to GeoJSON. We compared again the size of the two files, and then upload the GeoJSON file to web and desktop application to try to understand how it worked. So here we have, we wanted to, let's say, to simulate a survey, a study on restriction in the urban development planning using data that are available online. So we downloaded the dataset from the open data of Regione Lazio that are data about archaeological area of Lazio in shapefile format. What we did was to upload these 4 different shapefiles. There were 4 because we have 4 different layers, 4 different geometries in QGIS to visualize the data, the geometry, and to visualize the attributes that are linked to it, to each research. After we exported each set of geometry, so each layer, to GeoJSON, and we needed to change the reference system. It was necessary because GeoJSON supports only one coordinate reference system, that is WGS 84. We compared the shapefile downloaded, as you see here, from the website of Regione Lazio, and the same resources just structured in the format of GeoJSON. We can notice that for almost the same, let's call size, that is 10 mega, almost for both, in one case we have 33 files. On the other side, we have just 4 files. So that is the files equivalent to the geometries. So by now, you can imagine the advantage of having 4 files instead of 33. Since we wanted to have all the resources that are emitted, that are 7,363 resources in one file to optimize the functionality, we uploaded the 4 GeoJSON files to a web application that manages GeoJSON map data. As you see in the slide, all the resources have been get together in almost 1 million rows. We query some feature, as you see here, to understand if all the attributes have been preserved during this changing format, let's say. And as you see in the slide, we have the attribute table here, this attribute table here with the information. And it is even possible to edit this attribute table with the add row on the left. So at the end, there is even the possibility to save your data set in a repository through GitHub. Then we wanted to upload this only one GeoJSON that it became just one file, one GeoJSON file in a desktop app open source. Firstly, we uploaded it to QGIS, but for one file, what happened that QGIS split the file in three layers that belong to the three different geometric primitives. So we decided to try another tool for managing and editing spatial data, that is Java OpenStreetMap Editor. You can query each single information. Here in the slide, you see an example of a query, this slide, sorry. You see a query made for searching all the villas inside the dataset, and the query has been made on the single layer that contains all the geometry. So the results concern point, line, and polygons. And in a very clear way, you can see here that all the attributes have not been lost, so have been preserved, and actually there have been a normalization of the field of the attribute table, so they still have the structure of the attribute table. So these are our conclusions. That what we wanted to say is that a system like this, with a spatial data that are structured through standards that are shared by the scientific community, fits perfectly into the theme of spatial big data that for sure will come soon. We underline the importance on having a format like GeoJSON that, differently from shapefile, is transparent, is clear, and it is possible to reuse it. And for sure, it opens new possibilities for integrating data. The last 2 points regards to, let's say, two questions, two challenge that we want to face in the future. That is how it is possible to have to preserve the topological information in this format, and now it is important to choose a format for them that preserve the topological information instead of the others, and how the GeoJSON fit in the theme of semantic web, in the theme of linked open data, and the format like RDF. So thank you for your attention, and sorry for the inconvenience at the beginning.
Thank you very much, Francesca and Andrea, for your interesting presentation. Are there questions? There is one comment by Julian. The comment is that GeoJSON is not very friendly with QGIS for complex geometries. We have seen at the end of your presentation, it keeps crashing. We had to turn to GeoPackage for SVP and export to GeoJSON for web application. So this is only, but it is only a limitation of QGIS. Your idea of working with Java and OpenStreetMap, I think it's a good idea in this case. I appreciate your presentation because it's easy to talk about open data, but if we do not talk about open format, most of our talk are unuseful at all.
That's the point. And, that's the point. Yeah, that's why we wanted to focus on this, on the format, because they are very, very important, because we can start here to talk about data, open data, and all the repositories. But if we put on our repository data with a format that is impossible to be read by people, it becomes difficult to have a shared knowledge with the scientific community.
Yes, Julian wrote another comment that was what you have said before. Is readable. GeoJSON is readable for humans, so this is a good opportunity for using it.
That's it.
And, yes. So thank you very much.
Thank you too.
I think have a question? No. So thank you very much for your very interesting presentation.
Thank you.
Now we have the coffee break. The coffee break. So we have 10 minutes before the next presentation. And if you want, you can go to our bar for talking about the presentation, for talking about ArcheoFOSS and taking a coffee, unfortunately, at home. So see you later in 10 minutes. Hello everyone. We are back to our afternoon session. We have seen during the coffee break a demo of PATH project, and we can see the link on the screen in a few seconds. I hope so. The link is not going on the screen. So, okay. We are waiting for the link in a few seconds. Okay, thank you very much. This is the link to the demo of the PATH project made by Julian Bogdani that illustrate better many of the things that Julian before said during his presentation. So thank you very much to everyone. We can start again with a new presentation. The new one, the next one is Open Data, Open Knowledge, Open Science, the new open lab of the Institute for Heritage Science, and is by Alessandra Caravale, Alessandra Piergrossi, and Irene Grossi. So I give the screen to Irene Grossi. Thank you very much for your participation, and we are very good to hear you.
Thank you, Gabriele, and thanks to all the organizing committee of ArcheoFOSS 2020. So I share my screen. Okay, can you see it? I hope it's working. Okay, so an interdisciplinary group, including archaeologists, philologists, computer scientists, and mathematicians, has gathered over time around the open access international peer-reviewed journal Archeologia Calcolatori. The work of Archeologia Calcolatori's group has not been limited to the scientific and editorial activity on the articles to be published in the journal, but has had broader scopes, aiming at monitoring and studying the use of digital data collections and the open access policies in the humanities field. The journal has therefore played a double role. On the one hand, it has been an international aggregator of projects, ideas, and reflections about the application of information technology in archaeology and human sciences. On the other hand, the editorial team has built over time a laboratory focused on open data, open science, and open digital resources in the archaeological sector. This research group has recently found adequate space within the Institute of Heritage Science at the CNR, a new hub which brought together the 4 CNR institutes are conducting research on cultural heritage on different aspects, comprising humanities, historical processes, experimental sciences, and technological applications. Because of this interdisciplinarity, the Institute is currently compiling a registry of the competencies in the heritage science sector, using semantic taxonomy techniques, which will be based on the analysis of projects and publications in the bibliometric as well as non-bibliometric sectors. Among its various objectives, the Institute has the mission of supporting innovation in the knowledge management, conservation, and enhancement of cultural heritage. In line with the CNR policies, the vision of a participatory science has been pursued by our Institute since its inception, as shown by the involvement in digital infrastructures linked to heritage science, such as IRIS and the Hyperion HS. Archeologia Calcolatori was born in 1990 as an observatory of theoretical and methodological aspects of computing and information technology applied to archaeology. Since 2005, it has joined the Open Archives initiatives, and an electronic version of the journal is published under the Creative Commons license behind CND 3.0, simultaneously with the hard copy publication. The case study of Archeologia Calcolatori demonstrates how, for an electronic scientific journal, the adherence to the open access policy and the effort to promote it are necessarily connected with a theoretical reflection aimed at exploring novel solutions to share scientific data and with their practical experimentation. The theme is topical in this moment when open science is a priority at the international level. In 2016, a new set of principles has been designed, expressing the kinds of behaviors that the researchers should expect from contemporary data resources. Findability, accessibility, interoperability, and reusability, FAIR, sum up and formalize the guidelines to enable reuse of data by academies, research institutions, and scholarly publishers. Those principles had already been at the base of all the open access and open science movements over the years. As advocated by the European Commission and recommended by UNESCO, they now play a decisive role in outlining strategies and valuable tools for the research community. The challenge nowadays is to refine and expand their applicability, defining controlled vocabularies and ontologies, suitable quality data, and metadata standards as solicited by the infrastructures supporting the dissemination and storage of scholarly content. Obviously, each discipline requires approaches and strategies differently shaped by the different type and use of data. This is particularly true in the humanities and cultural heritage sector, with its variety of practices and demands and a plethora of available dataset. A consequence of this heterogeneity is needed to find connections across multiple datasets and to agree on publishing policies, shared terminologies, and metadata specifications that are central to interoperability and reuse. The digital infrastructures that make the access to scientific resources and the conservation of data easier support the adoption of FAIR principles, as their remit is to create new opportunities and enhance the exchange between disciplines and researchers. Equally, a fair knowledge and a good data management are fostered by high-quality digital publication that can facilitate the ongoing process of discovery, evaluation, and reuse. Archaeological Calcolatori is an example of such a best practice, as its focal point are full open access, quality standards, guaranteed by peer-reviewed processes, and the ethical rigor of research. The commitment to open science and the early compliance with the FAIR principles has also resulted in specific operational choices regarding the management and dissemination of Archaeological Calcolatori's bibliographic resources. The journal has regularly updated the indexes of its publications on its website, where resources can be found both by consulting the stated index of the volumes and through a dynamic search functionality. Precisely to facilitate the retrieval and sharing of the contents in the ever-increasing amount of bibliographic resources on the web, in recent years, the journal has adopted the system of the digital object identifiers. The OIs are codes that allow to identify univocally and persistently the digital objects, and to easily find them in the net thanks to the localization of the services associated to the content. Born in the 1990s in the sector of digital publishing, their use is proving more and more effective in the scholarly publishing inspired by the principles of the open access. The registration of the OIs for Archaeological Calcolatori has started in 2016, immediately following an agreement between the CNR and the European Agency for the DOI registration. But even before the practice of registering DOI spread, Archaeological Calcolatori's resources had been provided with uniform resource identifiers in the repository of scientific open access literature, SOLAR, created in 2006 at the CNR Central Library. This early choice of depositing the metadata and the full text of the articles in SOLAR was crucial, not only as regards the findability principle, but also for reasons of accessibility, which is the second FAIR principle. As we said, to the aims of accessibility, the journal's website had been configured as a place for the archival and dissemination of the publication's content. The full text of the open access articles, for a total of over 15,000 pages, are available in PDF format and can be downloaded via a link in the web page describing each resource. However, given the volatility of the digital product and the ever-increasing mobility of the web, ensuring not just access, but a stable access to digital research products has become a concrete issue, so that long-term repositories like Zenodo have been largely promoted over the last years by national and supranational policies. SOLAR was one of the first initiatives in this sense, and as we will see in the conclusions to this paper, how the CNR itself is encouraging the dissemination and accessibility of the research products. A key to each of the above-mentioned advancements towards the findability and accessibility of Archaeological Calcolatori's resources has been the elaboration of their descriptive metadata. These have been recorded in the database of the journal, which has been implemented over 2 decades, both in content and technology, pursuing the path of the open science. Archaeological Calcolatori's database currently stores the metadata of more than 1,000 publications structured according to a simple model. This has in the article, volume, and author its main entities, and in the simple Dublin core the basic set of its attributes. Their relations return the complexity of the bibliographical resources description, which is refined by further ad hoc attributes serving the aims of the researches conducted by our group on the article's content. The choice for the compliance to the standards for metadata creation has paralleled the early adherence of the journal to the Open Archives initiative since 2005, and the exposure of Archaeological Calculatori's records according to the OAI DC metadata format in an OAI PMH repository to enable interoperability. The repository has been recently renewed with the provision of a further metadata format, the QDC. Moreover, for the integration with the Open Access Infrastructure for Research in Europe, OpenAIRE, a few months ago, the data exposed in the OAI DC format have been made compliant to the OpenAIRE guidelines for literature repositories, version 3, and domain-relevant attributes such as those regarding access rights, identifiers, resource type, and versioning have been aligned to standard vocabularies. This effort towards standardization and interoperability has eased the provision of bibliographic metadata to diverse initiatives of aggregation of cultural and scientific digital content. Thanks to an agreement between the then Istituto di Studi sul Mediterraneo Antico, now converging to the Institute of Heritage Science, and the Istituto Centrale per il Catalogo Unico, ICCU, Archaeological Calculatoris was the first set of data related to a scientific journal's production to be made available in the portal of Italian culture in 2017. The scale of provision of content to aggregators has been recently broadened to the European level. Thanks to a renewed collaboration with the CCU, the journal has contributed more than 900 resources to the Europeana Digital Library in the frame of the Europeana Archaeology project. All those portals, including the OpenAIREs, display the metadata of the records, but also provide access to the PDF files of the publications stored in the journal's archive, thus supporting in their turn the dissemination and accessibility of Archaeologia Calculatoris resources, and boosting the opportunities of data reuse also in a linked open data perspective. For instance, the provision of full text links among the metadata of the publications provided to the OpenAIRE in a dedicated DC identifier field allows the portal to retrieve the full text of the journal. These are reused by OpenAIRE for analysis through text mining tools in order to extract bibliographic references and project information, compute subject classifications, and so on. Aiming at sharing and reusing our scientific resources online, we also tested the application of web mapping strategies on the journal texts according to the criteria offered by the open source international tool Recogito. Recogito is a free online annotation tool and publishing platform developed as part of the Pelagius Free Research Project, used mainly for mapping toponyms mentioned in the ancient literature. Starting from digitized documents and basing on some specific gazetteers, Recogito allows to identify the geographical items cited in the text and to place them on a map. To carry on the work on the articles of Archaeologia Calculatori, it was decided to experiment the mapping according to two different criteria. One is chronological and the other one is thematic. The first one considered the articles published from 2014 to 2018, while the second one examined the selection of texts published in the first volume of the journal in 1990, where Etruscan toponyms are mentioned. As concerned the 2014-18 articles, the text mapping shows a wide distribution of the mentioned toponyms. The sites are found throughout the Mediterranean area and beyond. The sites of our peninsula are certainly predominant, though many are also located in two major islands of Sicily and Sardinia. In fact, in recent years, in these regions, numerous archaeological initiatives and projects applying information technologies have been carried out, and the results of many of them were published on Archaeologia Calculatori. The Near East area is also represented with numerous toponyms. In Western Europe, Spanish sites are prevailing. Regarding the thematic mapping dedicated to the mention of Etruscan sites, the most attested toponyms are Cerveteri, with over 120 mentions, and Marzabotto, with about 80. Their prevalence is not accidental, because both sites have been subject to particular attention by our journal. The first one, especially in the past years, thanks to the innovative research carried out by our institute as part of the CERE project. The second one, in more recent times, thanks to the investigations related to the Kainua project, aimed at reconstructing the architectural structures of Marzabotto to the most innovative digital technologies. The theme of linked open data is an important topic in the Italian and international debate related to the dissemination of cultural heritage through the web. Projects and initiatives increase at the national level, for example, those promoted by the CCU with Cultura Italia and the CCD with data.beniculturali.it platform, and at the international level, such as the work of the Getty Research Institute linked to vocabularies for art, architecture, archival materials, conservation, and bibliographic materials. Through the mapping made with Recogito, the toponyms mentioned in Archeologia Calcolatori became linked open data, and they have been connected with other geographical data through their inclusion within the Pelagios network, a European initiative that links information online through common references to places. So today, if you enter in Pelagios through its geographical search engine Peripleo, and search for example, Orvieto, you will see a list of some digital repertoires in which the site is mentioned, and among these also the citations of this Etruscan site made in the volumes of Archeologia Calcolatori. To conclude, based on the theoretical and practical experience of the research group gathered around the journal, the main target of the CNR ESPC research group on open data is the experimentation and promotion of protocols and strategies useful to the enhancement of open and shared scientific resources, mainly publications and datasets, with a focus on the area of the heritage science. This is in line with the policies of our institution that in 2012 signed the Berlin Declaration on Open Access to Knowledge in the Sciences and Humanities and supports the European Chart for the Free Circulation of Knowledge. And it is consistent with the CNR's latest initiative in the promotion and dissemination of scientific knowledge, such as the implementation of the OA Pub portal that you see here, which builds on the institutional repository of research products people and openly publishes the metadata of these resources with an emphasis on open access publications. Thank you.
Thank you very much, Irene. Really interesting your presentation about the link between open access and open data. Really, really interesting. I have a question. No question. No question in this moment. It was extremely clear, evidently. So thank you very much for your presentation and for explain all the tools that we have now for linking data and linking open data through gazetteers such as Pelagios or so on. So very, very interesting. Thank you very much. We are now at the point of our last presentation. Last presentation is about FOSS, Open Data e Open Content in Archeologia, breve storia, stato dell'arte e scenari futuri di Pier Giovanna Grossi e Marco Ciurcina. We are waiting for Pier Giovanna, that is okay. Thank you very much, Pier Giovanna.
Here we are.
Waiting for
Marco.
Pier Giovanna, that is okay.
Are you hearing me?
Thank you very much, Pier Giovanna. I have a terrible echo of my voice.
Waiting.
Pier Giovanna, that is okay.
Are you hearing me?
Thank you very much, Pier Giovanna. I have a terrible echo of my voice.
Sorry. Are you hearing me now?
Yeah. I hear you very well.
I forgot to stop the YouTube. And we are waiting for Marco too.
Hi, me. Hi, all.
Hi, Marco.
Hi, Gabriele. Hi, Pier Giovanna.
Okay. I present your paper few minutes ago. FOSS, Open Data e Open Contents in archeologia, breve storia, stato dell'arte, scenari futuri. Thank you very much to you both, and I give you the screen.
Thank you very much. I try to share the screen. Wait a minute. Here. Okay. How is the presentation?
It's okay. We can see.
Okay. Are you seeing everything?
Yes.
Okay. Okay. So, greetings, everyone. First of all, we apologize with English speakers because even if the slides are in English, we will speak Italian, since we will focus on issues and conclusions that relate mainly to Italy. This way, we hope to facilitate communication with local speakers, which are the research institutes and Italian public administrations. We are available at the end of presentation to answer any question you may have. Thanks for the attention. Allora, buongiorno e bentrovati. L'argomento che vogliamo proporre oggi io e Marco è alquanto ampio e complesso. Sicuramente lo eviscereremo meglio in modo più completo negli atti. Oggi ci concentreremo principalmente su due temi. Quello del diritto digitale, che ormai è parte della quotidianità di tutte le persone, indistintamente dal luogo in cui vivono e dal ceto sociale a cui appartengono, e il concetto di bene comune, che è un concetto presente in tutte le epoche e in tutte le civiltà. Senza bene comune non è possibile costruire una società, non è possibile il progresso. Ma cosa c'entrano? Aspettate che allora devo però controllare. Ecco, avevo dimenticato di mettere lo schermo intero. A cosa c'entrano questi due concetti con quello di beni culturali e con il suo sottoinsieme dell'archeologia? È indubbio e forse ovvio che la conoscenza dei beni culturali non può prescindere oggi dall'information technology e dal diritto digitale. Il concetto di bene comune, del resto, ben si sposa con il concetto di bene culturale, e meglio ancora con la sua definizione anglosassone di eredità culturale. Senza una eredità culturale che ci accomuna non è possibile costruire civiltà, no, società, non è possibile pensare né alla conservazione della stessa né al suo progresso. E del resto, in sintesi, è anche quanto sancito dalla Convenzione di Faro, avviata nel 2005, ratificata da 19 paesi e finalmente anche dal Parlamento italiano il 23 settembre scorso. Con questo il numero di stati aderenti arriva a 20. La Convenzione di Faro mira a stabilire il valore del patrimonio culturale per la società. In questa slide ho inserito solo due articoli della Convenzione di Faro. Cito solo l'articolo 1, ma anche tutto il resto del testo è un'unica grande e forte dichiarazione del legame tra comunità e bene culturale. L'articolo 1 riconosce infatti che il diritto al patrimonio culturale è inerente al diritto a partecipare alla vita culturale, così come definito dalla Dichiarazione universale dei diritti dell'uomo. Riconosce una responsabilità individuale e collettiva nei confronti del patrimonio culturale e sottolinea che la conservazione del patrimonio culturale ed il suo uso sostenibile hanno come obiettivo lo sviluppo umano e la qualità della vita. L'articolo 14, lo cito perché si ricollega al secondo concetto di cui vogliamo parlare oggi, riconosce infatti l'importanza dell'information technology per i beni culturali, per migliorarne l'accesso e i benefici che ne derivano, e incoraggia gli Stati membri, ad esempio, a supportare standard compatibili o a superare gli ostacoli nell'accesso alle informazioni. partiamo dunque da questo, dall'information technology e dal diritto digitale. Giusto per fare una brevissima panoramica storica, agli albori dell'informatica gli utenti utilizzavano soprattutto software sui loro dispositivi. È in questo contesto che si sono sviluppati due modelli, quello del software proprietario e quello del software libero, basato sulle licenze libere di software nate all'inizio degli anni '80 per tutelare la conoscenza del codice sorgente. Nel nuovo millennio c'è il passaggio agli smartphone, il software libero è il più utilizzato in questo ambito, ma in sistemi ormai completamente chiusi. È il periodo in cui si inizia anche a discutere di accessibilità e distribuzione dei dati. Nascono associazioni per la cultura libera come l'Open Knowledge Foundation, l'Electronic Frontier Foundation e si potrebbe andare avanti con un lunghissimo esempio. E infine, seppure l'origine di queste tecnologie risalga ben addietro nel tempo, è dopo il 2000 che si fa strada alla nuova prassi del cloud storage and computing con i suoi pro e i suoi contro. In conclusione, stiamo parlando di un settore in rapida e continua evoluzione e a questa evoluzione tecnologica si affianca un necessario e continuo aggiornamento del diritto digitale connesso. Qual è la situazione attuale? Da un lato possiamo ormai affermare con certezza che il software libero è stato sdoganato a livello internazionale, perfino Microsoft e Google hanno progetti di software libero. L'attenzione oggi è concentrata sui dati e sulla gestione dei dati, sul formato e sulla licenza che ne consentano l'uso e il riuso e sui servizi che ospitano i dati, che devono rispettare garanzie di accessibilità, di conservazione e di riuso. Ma cosa vuol dire fare open data? È stato Tim Berners-Lee a dare una definizione di cosa è open data e cosa non lo è, e a dare una definizione del diverso grado di apertura che corrisponde a un numero di 5 stelle. Quando si parla di open data a una stella si parla di dati che vengono pubblicati in dato non processabile, ad esempio un PDF. 2 stelle sono i dati che hanno un formato processabile e standard, 3 stelle sono i dati, i dati che sono in formato, 2 stelle i dati in formato processabile, 3 stelle i dati in formato processabile standard, 4 stelle i dati che hanno un URI che li identifica univocamente sul web e 5 stelle i dati collegati ad informazioni esterne. In sintesi, ecco, in questa slide viene un po' riassunto questo schema. Il PDF è il formato di open data minimo pubblicabile online. E questo per gli open data. E cosa vuol dire usare servizi che garantiscano l'autonomia, la libertà, la conservazione e la divulgazione? È usare servizi cloud e servizi online di cui si possa controllare la localizzazione fisica, che utilizzino codice sorgente aperto e che propongano licenze d'uso rispettose degli utenti. Alcune problematiche in questo contesto riguardano proprio il controllo dei dati. Il controllo dei dati che non va sottovalutato perché i dati danno un potere strategico. Non sono poche le azioni di antitrust condotte a livello europeo, oltre che poi anche a livello più internazionale, nei casi di rischio di monopolio. E quali sono in questo contesto le prospettive future? I governi hanno un ruolo fondamentale nel garantire la libertà e l'autonomia e le comunità non governative hanno un peso sicuramente fondamentale, in particolare si instaurano cooperazioni. Un esempio che verrà citato anche in seguito nelle slide è quello di Wikipedia, oppure quello di Wikimedia, della Wikimedia Foundation, e quello di OpenStreetMap, dell'esperienza di OpenStreetMap. E infine deve essere attuato un piano di forte difesa dei formati e delle licenze, dei formati standard e delle licenze aperte, che sono garanzia di preservazione dei dati. Passiamo ora, ecco, questo era un po' un'introduzione generale sul contesto dell'information technology oggi. A livello dei beni culturali cosa succede? Anche nel nostro settore si può dire che il software libero è stato sdoganato ormai da anni, forse spesso utilizzato più perché è gratuito che perché è libero, ma è sicuramente una tipologia di software molto utilizzata. E come siamo messi però a livello di open data e servizi? Partiamo da una panoramica a livello internazionale e vediamo cosa succede nel resto del mondo prima di ritornare in Italia. A livello internazionale la necessità di condivisione dei dati e il senso di comunità sono sicuramente sentiti. Ho inserito nelle prossime slide alcuni esempi presi da diversi stati e da diverse istituzioni di ricerca e valutati in base alle 5 stelle degli Open Data di Tim Berners-Lee. Ho preso solo alcuni esempi, spero che chi è stato escluso non me ne voglia, si è trattato solamente di una scelta di sintesi e certamente negli atti sarà possibile dare spazio anche ad altre esperienze altrettanto virtuose, tra cui quelle presentate, alcune anche presentate a questo convegno, cito solo il Roman Open Data, il portale romanopendata.eu, oppure anche il bel lavoro sulle iscrizioni irlandesi. Parto ora da un progetto presentato stamani da Benjamin Duke, quello dell'Istituto Germanico Lida World, che espone dati eterogenei, tra cui archivi e biblioteche. I dati dei tesauri sono esposti come linked open data, con URI in formato RDF, la possibilità di interrogazione Sparkle, e seppure non tutte le tipologie di dati possono essere esposte così, ad esempio i PDF dei libri, si può definire un sito che pubblica open data 5 stelle, perché lo fa dove possibile. C'è poi il progetto Pleiades, che è un progetto dell'Ancient World Mapping Center, dello STOA Consortium e dell'Institute for Study of Ancient World dell'Università di York. È un progetto quindi principalmente americano. Si tratta di un dizionario geografico costruito comunitariamente, una mappa, comunque ecco, molti di voi già lo utilizzano e abbiamo visto anche presenti alcuni sviluppatori al convegno. Si tratta di una mappa dei luoghi antichi e di un dizionario geografico che pubblica il link ed Open Data e quindi Open Data 5 stelle. C'è poi il progetto alla carte dell'Ancient World Mapping Center del North Carolina, è un progetto di mappatura dell'antichità, i dati sono scaricabili in formato processabile, non vi sono link ed Open Data. La licenza è stata aggiornata nel 2016, ho visto che in alcuni portali viene ancora ripresa la licenza vecchia, però dal 2016 la licenza di questo portale è una attribution, non c'era like attribution e basta, mentre prima era non commercial, quindi dal 2016 si può parlare di un progetto che pubblica dati a 3 stelle. C'è poi cito poi il Getty Institute, che pubblica diversi tesauri, ho preso qui in considerazione quello di Arte e Archeologia, è un thesaurus pubblicato in formato RDF con linked open data, ha una licenza ODBL, quindi anche in questo caso parliamo di Open Data 5 stelle. In conclusione, a livello internazionale non mancano esempi virtuosi, pubblicare Open Data archeologici è possibile. Vediamo però ora cosa succede a livello italiano. E prima di parlare delle esperienze italiane è doverosa una breve introduzione, una breve premessa sulla legislazione italiana, cosa consente e cosa non consente la legislazione italiana. E qui passo la parola a Marco per le prossime slide. Marco, ci sei?
2 slide.
Sì.
Sì, ci sono, dico, per le prossime 2 slide, non esageriamo, certo. Poi ti ridò la parola. Allora,
Vai pure, credo.
Ok.
Vai pure.
Il quadro normativo. Sì, vado. Il quadro normativo è articolato, diciamo. Certamente innanzitutto bisogna ricordare il diritto d'autore e i diritti connessi, tra i quali il diritto del costitutore di banche di dati, ma anche altri diritti connessi come i diritti sulle semplici fotografie nel caso in cui i dataset includano fotografie e altri diritti connessi che possono entrare in gioco. Questi diritti sono gestiti in modo ormai direi semplice dalle licenze libere di contenuti e di basi di dati che sono disponibili. Poi è molto importante tenere in considerazione i diritti di privacy, i diritti di riservatezza che ormai sono nelle orecchie di tutti perché negli ultimi anni abbiamo sentito parlare molto del GDPR, del Regolamento Generale sulla Protezione dei Dati, che è il nuovo modello normativo al quale ci dobbiamo attenere. Ora, il fatto che un contenuto, un dataset sia rilasciato con licenza libera non permette di dimenticarsi dei diritti di privacy. Quindi se nello stesso dataset ci sono dati personali, bisognerà rispettare anche i diritti di privacy degli interessati, delle persone di cui dati si tratta. Per fare un esempio molto semplice, i dati di Wikipedia sono, è vero che sono contenuti enciclopedici, però se uno scarica anche, che so, la cronologia di un contenuto, scarica anche gli indirizzi IP e i nickname delle persone che hanno fatto i contributi, quindi quelli sono dati personali. Poi è molto importante tenere presente il codice dei beni culturali, che sostanzialmente ha due previsioni importanti che riguardano l'accessibilità delle opere culturali, dei beni culturali. Allora, innanzitutto la necessità di richiedere un'autorizzazione, secondo la necessità di pagare un canone in certi casi, quando i beni culturali sono in custodia di certi enti preposti alla custodia, come il Ministero o enti territoriali che hanno in custodia beni culturali. Quindi in certi casi c'è da tener conto delle norme del Codice dei beni culturali, in particolare articoli 106 e seguenti, tenendo presente, poi ne parleremo tra un attimo, del fatto che in certi casi sia un po' liberalizzato il quadro normativo. Molto importante tenere presente il Codice dell'amministrazione digitale, decreto legislativo 82 del 2005, che per esempio contiene una previsione, di cui anche diremo una parola in più dopo, che spinge per la liberalizzazione dei dataset, dei database, delle banche di dati. Poi anche un altro quadro normativo che è importante tenere presente, anche se in Italia ha avuto soprattutto nel settore dei beni culturali vicende non esattamente felici, è il settore della Public Sector Information, che è attuato nel decreto legislativo 36 del 2006 e che dico non ha avuto vicende felici, perché la piena attuazione di questo quadro normativo in Italia fatica, mancano ancora decreti che rendano chiaro e semplice attuare le norme nel settore dei beni culturali, anche se è molto importante tenere presente che in arrivo dovrebbe essere attuata entro il 2021 una nuova direttiva che sostituisce la vecchia direttiva europea sulla Public Sector Information, la direttiva 2019-1024 Open Data Directive, che quindi dovrebbe semplificare un po' il quadro normativo. Sintetizzo dicendo che non finisce tutto qui, perché ci sono altri diritti che chiamo diritti privati su beni immateriali, sia diritti cosiddetti di proprietà intellettuale come marchi, informazioni segrete, ma anche diritti della personalità che possono entrare in gioco con la circolazione di dati e informazioni e contenuti di qualsiasi tipo, e poi eventuali obblighi, divieti di legge, diciamo, non so, il segreto di Stato, il divieto di divulgare mappe di aree militari o aeroporti e così via. Ok, se puoi andare avanti di una slide. Solo per ricordare le novità già attuate più importanti che favoriscono la liberalizzazione dei beni culturali, e quindi le modifiche di cui vi ho fatto cenno prima al Codice dei beni culturali e del paesaggio, in particolare l'articolo 108, sono state previste delle eccezioni il cui perimetro esatto è molto controverso, ma che comunque aprono la possibilità perlomeno di fare delle fotografie di beni culturali in custodia senza essere soggetti ad autorizzazione e pagamento del canone, quando fatte per uso personale o per uso di ricerca o altre finalità. Poi è importante anche questo menzionato prima, l'articolo 52 del Codice dell'amministrazione digitale, che prevede il principio dell'open by default, quindi in sostanza se manca una licenza a un dataset, si assume che quel dataset sia libero. Questo lo stabilisce l'articolo 52 del codice dell'amministrazione digitale. Poi molto utile, molto utilizzato, il FOIA, come si dice, no? Gli articoli 5 del decreto legislativo 33 del 2013, la trasparenza nella pubblica amministrazione, che offre uno strumento per accedere a dati disponibili nella pubblica amministrazione. Ti ridò la parola.
Grazie Marco. Allora, questa breve panoramica era un po' per introdurre la situazione italiana. Alcune cose non si possono fare, però diciamo che la maggior parte delle cose con i dati archeologici che abbiamo a disposizione si potrebbero fare, cioè è possibile pubblicare dati archeologici online, nulla lo vieta in Italia. Allora, per arrivare alla situazione italiana, vediamo in pratica che cosa succede in Italia. Parto da una bella sintesi e una bella panoramica sul FLOSS e gli open data fatta almeno dal 2006 da Julian Bogdani, che ringrazio e con cui mi complimento per il puntuale lavoro di analisi e di sintesi. L'unico commento che faccio a questa sintesi è che, seppure incompleta, ottima, è che dimostra anch'essa che il software libero è stato ampiamente sdoganato, ma dimostra anche che al diffuso utilizzo di software libero non corrisponde un'altrettanta diffusa partecipazione ai progetti di supporto al software libero, pochissimi infatti sono i progetti di sviluppo e non corrisponde nemmeno un'altrettanta condivisione di dati. Tornando quindi a parlare di servizi però, di cloud, di sharing e di dati, che è il tema su cui ci siamo concentrati, proviamo ad analizzare i progetti italiani prendendo come esempio proprio quelli presentati ad ArcheoFOSS nelle scorse edizioni per avere una panoramica su quelle esperienze che più di altre hanno cercato di pubblicare open data, di fare open data. Allora, parto dal progetto già presentato questa mattina, dall'ArcheoSitar Project. Purtroppo oggi non sono riuscita a verificare, come si è capito anche dalla domanda che ho fatto questa mattina, la licenza. Sappiamo che i dati verranno pubblicati in questi giorni con la licenza. Io per ora, quindi qui ho messo con un punto di domanda una stella sugli open data, basandomi sulle informazioni presentate questa mattina, però mi riservo di fare di dare una valutazione finale dopo che saranno pubblicati i dati. Altri progetti presentati all'edizione scorsa sono i progetti di mappa, anch'essi pionieristici come il SITAR, nati credo poco dopo il SITAR o negli stessi anni. Per quanto riguarda il mappa GIS, non sono riuscita a trovare dati scaricabili in formato processabile. La licenza però, anche un po' articolata, dipende infatti dal tipo di dati, intende essere aperta. Ho messo un punto di domanda sulla stella e in caso chiedo ai colleghi di darmi poi indicazioni per correggere sia la presentazione che poi il lavoro che presenteremo negli atti, nel caso ci siano invece dati scaricabili e processabili all'interno del GIS. Per il mod invece alcuni dati sono processabili, scaricabili e processabili, e altri invece sono coperti dal copyright. Quindi per il mod mi verrebbe da propendere per le 3 stelle, ma le 3 stelle non si possono ovviamente pubblicare alle relazioni di scavo coperte da copyright. Anche qui ho messo un punto di domanda e in caso poi ne possiamo parlare con i colleghi. Ho citato poi qui in questa slide i 2 progetti del SITAVR, che è nato da una collaborazione con il SITAR ancora diversi anni fa, e un nuovo progetto che è una costola del SITAVR, un progetto su un piccolo comune del Reggiano. Per il SITAVR devo dire che la maggior parte dei dati, confessare che la maggior parte dei dati sono ancora ad accesso riservato, non sono disponibili, ne abbiamo pubblicati solo pochissimi, è un progetto che purtroppo si è arenato principalmente per la mancanza di fondi. Il SITAVR invece è un piccolo progettino che è riuscito a pubblicare con un formato processabile, con licenza libera, un set di dati completo su un piccolo comune. Un altro progetto presentato all'edizione scorsa è il progetto Raptor, anche questo era stato un progetto pionieristico presentato forse nel 2012 ad ArcheoFOSS. Si proponeva in origine di sviluppare software open source e di pubblicare i dati. Qualcosa è andato storto perché oggi il codice è chiuso e nessun dato è disponibile sul portale. Infine, cito il SIGEC Web, il catalogo dei beni culturali, perché viene anche preso in considerazione in uno dei workshop. Anche in questo caso però devo dire che nessun dato è accessibile. In sintesi, qual è la situazione italiana? I dati italiani pubblicati, gli open data italiani pubblicati sono davvero pochi. Spesso sono accessibili solo con un accesso riservato, i dati archeologici in Italia spesso sono in formati non processabili e spesso hanno licenze che non ne consentono il riuso. Le prospettive future quali sono? L'Italia è sicuramente in questo momento in un processo che è in atto, in un processo di apertura che è in atto, un processo che è stato appena avviato, che ha ancora una lunga strada da percorrere. Un ruolo fondamentale lo giocherà sicuramente il governo, perché è con una legislazione adeguata, aggiornata e chiara che si potranno pubblicare i dati ancora conservati negli archivi. Un altro ruolo importante lo avranno le comunità, la spinta dal basso, come dimostra Wikipedia, OpenStreetMap, possono cambiare le cose, e infine è sempre fondamentale non abbandonare la costante e insistente difesa dei formati standard e delle licenze libere. Quello che si può fare, molti processi virtuosi sono stati avviati e attendono solo di essere migliorati. Migliorati come? In che modo? In due modi: cercando di avvicinarsi di più possibile agli open data 5 stelle e cercando di impiantare solidi servizi nazionali o locali di gestione e distribuzione dei dati. A livello sociale, cercando di fare pressione presso il Ministero e verso le pubbliche amministrazioni perché i dati vengano liberati. Con questo ho finito, io vi ringrazio per l'attenzione e io e Marco siamo disponibili per le domande anche in caso o per discussioni o per confronti anche nel canale Telegram. Grazie.
Thank you very much to Pier Giovanna and Marco for their presentation. I don't see question in this moment in the chat, so I can make a short comment about the MAPPA, Open Data and MAPPA-GIS. As for MAPPA-GIS, it's not an open data platform, it's an open access platform. You can navigate the data and you can download only CVS file from your analysis and queries. So the data inside in this moment are not open, are only open access. As for the MOD, Map Open Data, I'm very curious to understand which data are not open. Maybe formats, many formats are not open. That's true because we decided to publish all the data as the archaeologist produced them, because our idea was to push on the cultural needs in archaeology, and so we accepted all kind of formats, and many of them are not open, we know. But the license is open for all the data inside, except for some data related to images that was related to the legislation. And we talked with Marco Ciurcina about this, so we decided to put a non-commercial, blah, 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 unfortunately, license. Anyway, this wasn't a justification, but was for saying that we are now working for re-engineering all our archives. We have two different projects in this moment. One is called Mago, and will produce more data about Tuscany, and with a new interface, also web interface, and data will be available. So also the geographic data will be open. And a new re-engineering of the MOD, and we hope to add the star, if possible, and new data. For this, we also create a new journal that is called Archaeological Data. It's a journal where everyone can publish papers, but only if they also publish their data into MOD repository. So it was thought as a way for pushing on open data. That's for complete the information. So thank you for giving me the opportunity of adding information in about this. If there aren't questions, so thank you for your overview about open data policy in Italy. We know we have a long way in front of us, but we can say that 10 years ago we haven't a way at all. So now we have a way to follow, and we all open to follow it more and more rapidly, adding data with many stars as possible. Thank you very much to everyone for participating in our afternoon. It was really, really interesting with a lot of experience or analysis about data and open open formats. Now, unfortunately, is 4 o'clock in the afternoon, and we have to close our session, but we can start with our 2 workshops. Today we have one workshop about documentation of cultural heritage data with IDI field by Julian Watson, Sebastian Cui, and Fabian Reibschläger, and one about hands-on 3D survey collection, 3DSC for Blender, publish an archaeological site in a game engine as an optimized open world environment by Emanuel Demetrescu. So I hope everyone to have a good opportunity to follow our workshop, and see you tomorrow for the last, but not least, day of ArcheoFOSS. Thank you very much. See you later. Bye-bye.
Bye. Bye.